Okay, can you hear me?
Yes, loud and clear, Cuba.
Yes.
Okay, can you see my slides?
As well, yes.
Okay, excellent. So 2 minutes past 2 p.m. Let's wait one more minute. So we have 60 people and people are coming. Could everybody please mute? We hear some noise from the background.
Okay, I've muted everyone. Please unmute yourself if you want to.
Okay, thank you, Pedro. Okay, excellent. So maybe let's get going. The agenda is very packed this afternoon, but I'm very happy to see many people hanging around still after nearly 3 days of a very, very intense workshop. So great to see you. Very quickly, so this is a session, a workshop focused on CS3MESH, which is a global platform for scientific collaboration. We will, essentially, there are 2 parts. In the first part, we will give you the status update, so where we are now in developing this platform, and also how to participate in the CS3MESH. And in the second part, which starts at 4 o'clock, we will brainstorm on how to expand the activities of the CS3 community and CS3MESH in particular. We will tackle topics of interoperability, sustainability, and challenges with European Open Science Cloud, and explore opportunities for finding synergies, use cases, and extending the user base with the new research communities and research infrastructures. So there is a link here in this page with program details if you want to have a look. Rita, who has developed this program, has done a very good job in describing each of the presentations, so you can use this as a guide as well. And just one final word from me. CS3MESH is built by CS3 community for CS3 community. So the goal is to increase the value of your EFSS service and pave the way for the future, how to evolve it in the future. So your active participation is very welcome, everybody in the audience, and we'll have as a basis for some subsequent discussions on future participation in future activities, engagements, and directions of the development of the CS3MESH and the CS3 community at large. So I'll just stop here and I'll give the mic to Pedro, who will give us a quick overview of where we are with CS3MESH.
Okay, thank you. Okay, can you see my slides?
Yes, I can. Yes.
Okay, thank you very much. Okay, so yes, indeed, I'm going to give you a bit of an update on the CS3MESH4EOSC European project and also the CS3MESH, of course. So I didn't want to make this presentation basically a repeat of my presentation yesterday. So just a moment, because I just noticed my camera is off. Just a second. Okay, that should be better. So I try to go back a little bit to the to the essence of the presentation and also to add some little other bits, which I hope will be informative. So starting by establishing some common ground. So because I know there are also people maybe watching this presentation who did not necessarily watch my talk yesterday, or maybe don't know the Science Mesh that well. So the Science Mesh is the vision of a decentralized mesh of enterprise file sync and share nodes, based on a community which has been already operating since quite some years, for some hundreds of thousands of users. It's based on open standards, open source software, and the goal is to create a federated research space for Europe, as to promote open science, collaborative research, and to support basically the work that researchers do on a daily basis. In order to do that, we are implementing a technical layer, technical infrastructure, a platform we call the Interoperability Platform, which will allow these applications to communicate between them and to communicate with the storage systems. And we are doing so in close collaboration with the sync and share industry and also other commercial partners, as you will see. So this is just a summary of the partners who are involved in the CS3MESH4EOSC project. So a nice mix of research, NRANs, also some SMEs, as you can see. So some main highlights from 2021 on the European project front. So in month 18 we had our project review. So it's the 18-month review, which was basically the intermediate milestone in the project, in which the feedback was actually quite very, very positive, and in which we have also taken, of course, the chance to look at where we are in terms of a critical path, and concluded that we are doing actually mostly fine. There is a slight delay in vendor support, which is already being addressed, as you will see further in the presentation. We have participated in several conferences. We had the opportunity to tell people about the project in TNC 21, at DataCon, in which we had a full session, at the OwnClouds conference, Open Science Fair, the AGI conference, and also the IRDA Plenary 18. And in 2021, we also made a press release in which we, together with some other actors in industry, basically laid the groundwork for platform support on Science Mesh. So basically, in this statement, we announced the development of the plugins for the three main enterprise file sync and share systems, open source ones, and yeah. So in what regards that, I will actually give an update in further on. Just to tell you that along the way we also established some partnerships. One of them, of course, with PandaSource and Muse, which are companies who are working on platform support. The Scribu Online, a product originally developed by University of Technology in Sydney, and which we are collaborating with when it comes to the open data task. The same goes for Scribu RDS. Then in terms of data transfers, the data transfer prototype we are developing, that's a collaboration, or we had a synergy with our clone, actually contributed code back to the upstream project, and ongoing collaborations with EGI and HIFIS. We're trying to set up additional activities which were not initially foreseen in the project, as to bring the Science Mesh to communities which currently are not integrated, are not part of the CS3 community. We've also refreshed the Science Mesh IO website and published a new version of the CS3MESH4EOSC use site as to reflect a little bit better the current state of the project. We, of course, in the meantime, have done a lot of work, and we had to catch up with that work and make sure that everyone is informed about it. So, as I was saying before, platform support that's currently being handled by PonderSource in terms of when it comes to Nextcloud, and also on Cloud 10, since there's similarity in the code base, of course. So the Nextcloud part is in an alpha stage, and the own cloud part will the on Cloud 10, of course, will be coming in March of this year. There's still some work to do, UI work, when it comes to OSIs, since the backend, of course, is already handled by the simple fact that Riva is integrated into the product. C-file is still under discussion. We are trying to find the best way to proceed together with the vendor, and there will be some news soon. Another thing we have worked on last year was the mesh directory, which now exists. It's basically the point you end up at whenever you click one of these links in an invitation you receive to share content with some other person. And it basically redirects you to the corresponding authentication system as to establish a trust relationship between the two parties. So once that's done, you can start using the applications which we are setting on top of the platform. So from the initial use cases that we had already presented last year, we have developed a series of prototypes, which are now all of them reached the proof of concept stage. Some are already actually quite usable. In others, we are still giving the last touches in the user interface. But anyway, they will be detailed further on into this workshop, I believe, in Holger's presentation. We are also, of course, working on bringing these applications to user groups. We're still identifying some of them. For some of these prototypes, of course, we have very clear targets. For others, we are still looking to them. So if you think this will be particularly useful to you, and you will see more about it further on at the workshop, please ping us and let's talk. We are also onboarding first early adopters. For instance, we had the PonderSource join the mesh recently and going through this onboarding process, which allowed us to get a bit of an idea of how complex it is and try and solve some of the pain points. And of course, as I have already mentioned in yesterday's presentation, we are trying to develop, since now the main components, main technical bits are in place. We're trying to develop the EOSC side of the project, so the integration with EOSC, and see how this whole ecosystem will fit into the whole vision of EOSC. So bringing the federated layer into EOSC. One activity we think is a low-hanging fruit is to provide a service node to researchers with no institutional access, so a standalone node which would be part of the mesh and anyone could use if they don't have access to the science mesh from their own institutional platform. And we've also got representatives in several of the task forces of EOSC who are following up on the latest developments. Then, still in the context of this EOSC integration, we have an ongoing activity I've already mentioned with EGI, and it concerns the integration of compute resources from EGI on science mesh nodes. So something which we hope we will soon be giving some news on. And of course, there are lots of discussions going on with research infrastructures, with user groups, and you will hear actually from some of those today. Finally, yeah, there's also collaboration ongoing with HIFIs on bridging the two federations and making sure that HIFIs users can benefit from the added value of the Science Mesh. So we are, of course, trying to leverage the community, which is an essential part of the initiative. And although there are only 12 partners in the project, we of course are aware that this is a community project and that the community is essential, and we are inviting everyone to join. And in the presentations that will follow, you will see there are many ways in which you can contribute and already start using the mesh, or at least seeing how it can be useful to you. So I will just finish by giving a bit of going a little bit over the changes we've done in our communication channel. So starting with ScienceMesh.io, in which we have created a new splash page, which we hope will be more informative, a nice vertical layout which allows you to quickly see the main points of the platform. A part where actually you have different tabs per use case, and you can access links to relevant resources that concern those use cases. So for instance, if you're a developer, you can access the GitHub repositories, you can join our Gitter chat, and you can even see in the documentation how to integrate your application. And that, speaking of documentation, that's the developer.sciencemesh.io site, where we have rewritten a great part of it, and it should be now much easier to follow, and much clearer in terms of what you want to do to join this platform and to install some of its components. We also have an application catalog where soon you will find links to the demos of the different prototypes, and there are also direct links to the corresponding GitHub repositories. Finally, the CS3MESH4EOSC EU website, where you can find all the latest news if you want to really follow up on what we are doing on a daily basis. Let's say the events we are attending, the activities we are doing, press releases. This information is on the CS3MESH4EOSC site, which is more of a project site more than a product site. Yeah, really advise you to visit it and to have a look and see what we are up to. And yeah, finally, there is the Graph dashboard, which will be soon accessible from the ScienceMesh.io website, and where you will be able to see the latest data. We're still finishing up some of the statistic taking bits. And once that's done, it will be accessible from the site. But we hope to see you soon also on this map. And I believe that's it. Thank you very much. And if you have any questions, please go ahead.
Thank you, Pedro. Are there any immediate reactions or any questions to what Pedro presented? I don't see right now. So perhaps let's move on, and let's move on to Ron, who will give us an update on Science Mesh from the point of view of an EFSS service provider. So if you are what actually makes up the infrastructure of the Science Mesh, and also what it takes for if you're running a service, what it takes for you to join it. So Ron, are you here?
Yes, I'm here. Can you hear me?
Yes, we can hear you well, and the slides are also.
Okay, let's get started then. Okay, CS3MESH for EFSS providers. Well, of course, during the last couple of days, you probably have heard this term many times before. EFSS, Enterprise File Sync and Share Services. So, I'm trying to go to the next slide, but there we are. Okay, what I'm going to talk about the next, let's say, 20 minutes or so is a very brief overhaul. What is the CS3MESH? In a little bit less detail as Pedro did. Tell you something about the architecture, about authentication, authorization that we apply, and more particularly also the invitation workflow, in which a lot of the good stuff about the CS3MESH is based on this. About monitoring of the CS3MESH, users metrics, operational procedures, governance structure, security, and finally let's say how to join the mesh, and give you a lot of links to more information. Okay, the CS3MESH, as Pedro said, it's a community of already running sites with having a sync and share services. They already have their own user base, and they decided to collaborate together in the CS3MESH. Although these CS3MESH are autonomous sites, they do not really depend on anything, but within the CS3MESH, they are bound together by protocols, procedures, and also policies. And by doing this, they provide services that allow their users to collaborate in terms of sharing data and applications. And from the very start, being lightweight is at the very core of its design. So speaking about design, this is, let's say, a schematic overview of the architecture. What you see is a number of sites, here 3, to be exact, which is the actual mesh. And there's also a central component. And the central part holds different components, consists of different components like the availability monitoring. So sites are periodically monitored, usage metrics, collecting metrics. For example, like how many shares do you have, how many users do you have, how much data is stored. There's also a database collecting the mesh topology of what sites are part of the CS3MESH, also with the contact information to security people and also site contacts. And last but not least, also a help desk, not for end users, but specifically for sites who are in need of help. There's also the executive module that runs at every site, and I will talk a little bit more about that later on when we discuss the invitation workflow. But yeah, that allows for service discovery in the CS3MESH. Also present you with a wave when you're trying to set up a trust relationship through the invitation workflow. Site admins can enforce local sharing policies. So if you do not allow your users to share this or that to somebody else, then that's the place where you can prevent that from happening. So in any case, you as a site admin, you are completely in control, and you also stay completely in control. And like I've said before, establishing trust between users and sharing resources, that is what the executive modules is about. And as I've mentioned before, sites run completely autonomous, means that if for any reason the central component will be down for a few hours, the CS3MESH will continue to function because the components do not really critically depend on it. At the moment, the test bed is has the size as it is now. The sites are in this graph. Well, let's say recently we've added a Ponder source to the mesh. They have a branch in Amsterdam and also in Utrecht. So I took the liberty of taking the Utrecht branch because otherwise their pin will just completely overlap the serve one. But this is the science mesh as it is today. Now something about the invitation workflow. Of course, if you have a sync and share service and you're, let's say you want to use your favorite AI system, you're very welcome to keep doing that. Of course, you can use a federated AI system. That's absolutely not a problem. But for the functionality of the mesh currently, it is not really necessary. And the reason why that is that we have an invitation workflow, which means that, well, in this case, Miroslav at Chestnut wants to share a file or a folder with Hugo at CERN. Then an invitation goes Hugo's way with a link in it. And this invitation can be sent by either WhatsApp or email or whatever means there is. Hugo, through the link, Hugo, let's say, is redirected to the EM, the executive model of Chestnut. He sees a wave. He selects his own institute, being CERN. He logs into that to his own EFSS instance and accepts the let's say the invitation, and then also there is a key exchange which allows for, the information that is exchanged here is that Miroslav now not only knows the user identity of Hugo at his own sync and share service, but also the name of this sync and share service. That information is transferred to the Chestnut site, and then based on that you can let's say continue sharing files, folders, applications, what you will. So for a more in-depth discussion of this, I refer to Milan's talk earlier this week. This is the central component in a little bit more detail. Apologize for, let's say, for all the technical details, but I'd like you to tell you something about how the mesh really works. The central component consists of the GogDB developed during the EGE projects earlier. And that is the central database where the site contacts and the site endpoints are kept. There's also Mantix that collects that information and provides it to other services that require GogDB information, like, for example, Prometheus, which collects information about, let's say, metrics that the sites are publishing. And there's also, we have a black box exporter that runs probes periodically to test the functionality of the science mesh. And there's also an alert manager that can inform sites that as soon as tests are failing, that the site is being informed in a timely manner. And altogether, this information ends up in the dashboard. But this is one has already been shown by Pedro in his talk. There's a Grafana dashboard with all the statistics, and hopefully we will see you there too soon. And there is also the monitoring page, where you can see which sites are not available, and who are available and who are not available. Of course, now about the more official part. This is more the technical part, but now the more official part of the mesh is operational procedures. And this work was carried out earlier this year. There are, let's say, the operational procedures like being admitted to the science mesh, and also how shall I say it? What you need to do to leave the science mesh, and also if you don't comply with the rules, you may be you may be suspended. And so we also have a procedure for that. And there's also information in there on support. We have for scalability reasons, we do not have a help desk for end users. Of course, as you may know, that the total number of sync and share sites in Europe altogether have something like several 100,000 users. So you don't want to see tickets from them, so that would not scale. So we only have a help desk for sites, and of course help desk for end users that is supposed to reside at the sites themselves. About mesh governance. At the moment, we have 3 bodies for that. There's the steering group containing representatives of all sites. And they decide on policy changes and things by a majority vote. There is the CS3MESH executive board. It's some kind of an overview board. For now, it's representatives of sponsors of the central services. Of course, the central services require money to be operated. So the people that sponsor that get a seat in the executive board. And it also ratifies decisions made by the CS3MESH steering group. The people with the hands in the mud, that's the operational team. They do the operations of the central component, of the central component of the CS3MESH. Are responsible for support and also, let's say, are involved with reviewing and approving memberships of sites and the like. And there's also a declaration document which needs to be signed by a site who wants to join the mesh, and that contains a number of responsibilities that you, let's say, have to take upon yourself, like things like having a terms and conditions policy locally and have a privacy policy and things like this in place. Security, a few short words about security. Like everything is supposed to be lightweight in the CS3MESH, so is security. So we heavily depend on the expertise and the knowledge of the local security teams. At the moment, the security procedures are a work in progress that are nearing completion, I should say. They're based on the ARC policy development kit. And for now, we have an incident report procedure, and there's also a service operation security policies. What we plan to do later on this year, in the autumn of this year, is also pen testing of the software. And now a small disclaimer. What I've just discussed earlier, like the governance, operational procedure, help desk, security. What we have now is still in a draft state. That is just a first thing to get us started. But of course, it's still under discussion. And at the moment, the CS3MESH itself is not yet in production. That's supposed to happen later on this year. But as we go into production, we want to test out these procedures and see what goes well and what does not go well. I expect there's some polishing that need to be done still. So it's still a work in progress. And of course, if you want to have a look at it and provide us with your comments, then you're very welcome to do it. About, let's say, the development.CS3mesh.io website, that is where you find all the more technical, more detailed information. That's basically the stuff, it contains the stuff that I talked about in this afternoon. And most importantly, there are also a number of steps listed there to join the CS3MESH. The last couple of weeks, it had a complete overhaul, that website. So it looks quite nice, I think, now. So here the necessary steps to join the mesh is you need to have a supported sync and share system. And for now, that will be Nextcloud and OwnCloud. And C-file is under development. There's also, you see that on the right-hand side, there's a mesh application form. You can fill that out, and there are just details in there, like the name of your site, and your security contact, and your site contact, and information like that. It's not that much. Just maybe in a minute you can let's say, fill everything in and submit it. You need to install the REVA, the Interoperability Platform. Information on how to do that, it's also on that website. Then you have to register in a central database, the POCDB, to provide your site information. Locally at your site, you have to set up the monitoring, make sure that your site can be monitored, and also that metrics of your site can be collected. And a little bit grayed out, that is the formal paperwork, like signing declarations and things like that. For now, we just skip it because we're not in production yet. And also, we would very much welcome if more sites will join the mesh and try to help us to building this infrastructure, and not by not be scared by paperwork and having to run to your legal department right away. So for now, we will just skip that step. And of course, if you want to reach us, well, an email address and the help desk are at the moment in preparation. I expect that to be operational in the next couple of weeks. But for now, you can reach us at Gitter. So if you want to get in touch with us, please meet us there. And I would also ask you to keep an eye on this website, development.sciencmesh.io, to keep yourself posted on the progress that we are making. And I'd like to conclude with a lot of links. Of course, the ScienceMesh.io website, the general information, and the developer site for more technical information. The documents I've discussed earlier, there are also links in there. They're all in Zenodo. Another recommendation is the glossary, because these documents are riddled with all kinds of acronyms. And if you want to understand what's in those documents, then it's also good to have the glossary nearby. And that's all that I want to discuss.
Thank you very much, Ron. Are there any immediate questions to Ron before we move on to the next speaker? There's some entries on the chat. One of the questions I have received in the meantime is what has changed in this testbed since last CS3.
Last CS3, well, let's say we are a lot further with, let's say, the operational documentation, also operational procedures, the security procedures. Maybe not that much on the technical side, of course, apart from the necessary upgrades of the software. But in the number of sites, it has slightly increased with 2 sites, I think.
Yeah, and I think we have a site from the, let's say, Direct Project Consortium, already the first site outside of the Direct Project Consortium, which is actually a very good sign of the components getting maturity. Yeah. And essentially the deployment procedures being streamlined, right?
Yeah.
All right. Thank you. So let's move on. And I think one of the big things, one of the big themes for the actual development of the federated architecture, this federated infrastructure, is the availability of the EFSS platform connectors. So essentially to expose this functionality, that the core functionality that is already there, to the end users through the EFSS platform, and also to the administrators in order to plug in this functionality to their EFSS platform. So I think that's one of the necessary key components where the project invested a lot last year in order to make them a reality. And now we will review what is the status of the Nextcloud, OnCloud 10, OSIS, and C-File application connectors. So essentially the apps you can install on your site and get connected to the federation. So first would be Michiel on the update on ScienceMesh Nextcloud app. Michiel, are you there?
Yes, hi. How's
Hello.
it going? I'll share my screen. Okay, so yeah, so I'll give a short talk about the ScienceMesh Nextcloud integration work, in which we're now starting to also backport to OC10. Just to recap a little bit about, or at least my understanding of how this fits together. So in ScienceMesh, everybody connects with an instance of Riva, of the Interoperability Platform. And so this part in the middle is a bunch of green Riva nodes that are connected together. But obviously, every site has their own file storage connected. So in this case, we're looking mostly about file sync and share, not other applications that you can connect via ScienceMesh. So in this example, there are, for instance, there's a FS site, there's an Uncloud 10 site, an OSIS site like CERN, for instance, and a Nextcloud site. And in order for this to work, we need connectors. So there needs to be a connector in Riva, and Riva's software architecture is very modular. So there's all these services that register themselves to provide the different backends. And so there's one for the user management, there's one for authentication, there's one for storage, which is an important one in this context, but also one for the shares and the invites. And these, I think that in OSIS and in FS, there are no specific things needed in order for Riva to connect to it. But in OC10 case and in the Nextcloud case, there is, and that's the part that Pondus had the honor of helping to develop. So first of all, we created backends for Riva that can use Nextcloud, or in the future also OC10, as the backend for most importantly file storage, but also for shares. So registering which shares you are sending and registering which shares you have received, only for the OCM shares. And the actual Open Cloud Mesh call that does the share across ScienceMesh is still handled by Riva. So when you someone shares a document or a folder with somebody else via ScienceMesh, then Riva handles the orchestration on the sending side. So it will handle to check whether the file exists. It will just ask for what is the metadata of this path. Does this file exist? Yeah, okay. And then it will interact with the user, and then at some point say, okay, create this outgoing share now. And then Riva does an HTTP call to the other Riva following the Open Cloud Mesh principle. And the other one receives it and then checks it, whether it's from an approved node, whether it's from one of the sites in the list of ScienceMesh. And if so, it will tell its backend, its shares backend, to say, okay, register the fact that there's an incoming share now. That's one side of it, using the EFSS system as a backend. The other side of it is that you're also using the EFSS system as a front end. So the user can actually use the graphical user interface of their EFSS system to say, I want to share this file with this other user. And if they have invited somebody previously via the invite flow over ScienceMesh, then that becomes one of the options with whom they can share a resource. And if they choose that from the interface, the graphical user interface of their EFSS system, then the communication goes the other way around. So it is the Nextcloud app or the OwnCloud app that tells Riva via a REST call to say, hey, create this share. And then Riva actually talks back to Nextcloud or OwnCloud again to say, oh yeah, I am creating this. So there's some back and forth there of the different layers. So from the user interface to Riva to the backend. And the way it looks in the user interface is that you have, for instance, in Nextcloud here, it's in Dutch, sorry, but you can, the Dutch word for ScienceMesh is still ScienceMesh. So this is what you see in the menu at the top. And from there, you have an option to generate a token. and this is the invite token that you would give to the recipient. And currently, as far as I understood, the discovery server is not yet online. So the way that the other user accepts the token is also through their EFSS systems. So there they just paste the token, and they know that they are at their where their own storage system is. And then it tells Riva to say, hey, we got an incoming share, and then it's, an incoming invite. And then Riva does the OCM invite forward, I think it's called, which tells the other Riva, like, hey, the token's been accepted. And after that, the sending user will be able to share with a ScienceMesh recipient. So when you share from Nextcloud or on Cloud 10, you will have an autocomplete text field where you type in the recipient. That just could be a local user. You see in this example, the second hit for, if you start typing M, is admin, which is a local user to this instance. And the first hit is you can share it with Marie at Riva2, which is in this case a test server where the sending Nextcloud instance asks Riva, like, oh, what are the accepted invites? And actually there was an invite accepted by this other Riva, which happens to also have an Nextcloud server behind it, but that's not relevant here. So all you see from the outside, the way sites join the ScienceMesh, they just look like identical Riva instances, and it doesn't matter which type of EFSS system is behind it. So that's also why in the URL here, you see the URL of the Riva instance and not of the destination EFSS system. But when Einstein shares a file with Marie, then next time Marie logs in, you see Marie is here logging into her Nextcloud server, and she gets this notification saying, hey, a new share arrived. Do you want to accept or reject it? And you say, well, this looks like a virus. Yes, I accepted this sharing request from Einstein, but I think he's sharing the wrong file now, or not. And then you say, oh yeah, this looks legit, and then you accept it. And then once you do that, it shows up in your list of files that were shared with you. And here again, and Marie is connecting to her Nextcloud server, NC2, but when she accepts the share, it looks like it's coming from a Riva server, which, as far as Marie knows, is that's all she knows. It's coming from one of the other ScienceMesh sites. So regarding the token invite format, we used token at domain name now, and that is because it's when I started developing this, it was my understanding that the receiving user would paste the token directly into their own system. I didn't know about the where are you from URL. So that will still change as soon as the discovery server is online. The tokens that get generated will be URLs that resolve to that server, and then Marie would select their own site and then take it from there. I don't know if we still want to support directly pasting the URL into Nextcloud or OnCloud. That would still work. We just parse the URL, but that's if not, we can just disable that part, and then we just tell people follow this URL, and from there you will be redirected to your own site. So the next steps from where we are now is that we have updated the Ponder source node in ScienceMesh to run this latest code. We are waiting for the CERN nodes to also update, and then we'll test between those nodes to make sure everything works. There's a number of known issues, but I guess we'll find some more in the alpha testing, which we're resolving. And we're porting the app to OnCloud 10. And there is the app framework is pretty similar. There's just a little difference in how shares are handled internally in OnCloud 10. And we hope to be able to give some tech support for other sites that want to update their ScienceMesh node So for now, most ScienceMesh nodes in the testbed are already sharing their stats, and we'd hope that people will update their existing app so that we can also actually start sharing resources over the ScienceMesh using Open Cloud Mesh over ScienceMesh. So and then if we get that working, if we get all the sites having their latest integration with a real EFSS server, then this is still the testbed. So this is not the Institute's real servers. So then at some point we will switch to our real servers and have the live ScienceMesh network, and that's of course why we're here. No, that's what we really are building. So yeah, my question to people here are who have a node in the ScienceMesh, or have a node that's not yet in the ScienceMesh, but they have an institute or institutes for which they provide EFSS, then saying yes, let's. I hope you will all join the ScienceMesh with the latest app that supports Open Cloud Mesh, and then we can all test it, and then we can push it further and get Open Cloud Mesh over ScienceMesh working, and then switch it to our real servers, and then we get maybe next year we'll do this. This whole conference will happen over ScienceMesh instead of over Zoom. That's my last slide. Are there any questions?
Thanks a lot, Michiel. I've got a lot of reactions on different channels, not necessarily on this Zoom chat, that it's great to see the actual interface of the EFSS platform getting almost ready. There's a question from Marcel.
Yeah, thank you for the talk. It really elucidated how it will fit together in the end, because I want our OnCloud to be connected, and we already have the ScienceMesh stuff running in the same cluster, and I was always wondering what I have to do to make it fit together. But so the OnCloud connector is missing, and will it be one RivaD and one OnCloud, or can I have one RivaD and multiple OnClouds and Nextclouds behind it?
I haven't thought about that. The simple way would be one Riva for each. Otherwise, Riva doesn't. So yeah, that's how. So sometimes
it's fine. Okay, I only want to know what I. That's
that means that we don't have to change anything to get it working. So one of the things, for instance, when you make when you're logged into the UI of your EFSS, then you're logged in with your browser with a cookie session, and then the EFSS makes a call to Riva to say, oh, the user wants this, etc. And then they mention the username, but they don't have the password of the user, obviously, because that was only seen at login and it's not stored in the session. So and Riva expects an authentication first before you do anything. Riva asks you to log in, but the EFSS system doesn't know how to log in its user. It doesn't because it doesn't know its password. So there's a loopback secret that it uses, where EFSS will ask Riva, okay, hey, can you do this and this for this user? And then Riva the first thing Riva does is a login to the user backend. Oh, sorry, I think my connection is frozen. Hold on. Sorry, am I back?
Yeah, I guess you're back. Yes.
Yeah. Sorry. Yeah. So there, because Nextcloud is asking Riva something, then Riva is asking this request to log in first, but the user backend is also the EFSS. So then it loops back. And the other thing is, when a request comes in to Riva from ScienceMesh side, then it has a separate secret with which Riva can initiate an action to the EFSS. And so these systems would work differently if you have one Riva and multiple EFSSs.
Okay, so yeah, if you don't need to change anything to make it work in a one-on-one, that's fine then. Let's first do the easy way. Thank you.
Okay, I think this is perhaps a good moment just perhaps to very quickly discuss or exchange some ideas. So what could be the next steps for someone who is not yet part of CS3MESH to join the federation? So I think the first step would be essentially to install the backend, so the Riva backend, and there are also some already connector apps which allow you to declare your site in the CS3MESH. So you could appear on the map, you could install the backend, and you could test compatibility with other sites. And then when we have this front-end connector ready, which I guess is a matter of next few weeks, if I understand correctly, then as a next step, you could essentially install that connector app into the front end and essentially test it in the testbed with the end users. There is a hand from Mark. Mark, please.
Yeah, a question on this, because you mentioned that you just installed the backend, but in the presentation from Ron, it was also mentioned that you have to register yourself in the Contribute and some other stuff, services. Is that automatically done by installing the backend and configuring the backend, or do you have to go through those other steps as registering in Contribute and the other services separately?
I think Ron should answer that. I guess he's trying to make it as lightweight as possible for the testbed. But Ron, I think you have to fill us in with the details here on how that should be done.
Well, first of all, I would just start, let's say, following the steps on the website, which is very lightweight, and start with installing the backend. And of course, if you have a Nextcloud instance, then install Ponder Sources app as soon as it's available.
So maybe what...
But for joining the mesh, it's not right away mandatory to have this app right away.
Okay, so maybe we could show, actually, since this is a live workshop. So I would go here as a service provider, and I would click here to access the installation instructions. Is that right? Let's have a look. And then here you have all the instructions how to join the CS3MESH. And I think, Ron, as you said, probably not all of these formal steps are necessary for the testbed, right?
No, there's also a disclaimer in there that it's even right there in the text, that it's still in draft state and that for now we just skip it. Okay.
So essentially you go to the CS3MESH.io, you go to the service provider, you're the service provider and you want to set up a CS3MESH node. You end up on this page, you follow these steps. If you have any feedback on this documentation or on this process, we would be very grateful to hear from you. And actually we'll also be happy to assist you in this.
Okay, thank you.
Okay. Any other questions to Michiel?
Just to add to the latest remark, if you join the Gitter chat for CS3MESH, then there are people ready to help there. And so that's what we did in October. And then Daniel helped us to get connected. And so that's always useful. Just come to Gitter and then people will help you, walk you through it.
Okay, great. This is a great remark. So let's show people how to go to Gitter. You go to CS3MESH.io. Okay. And then I guess you go to community and Gitter here. Okay. So you are 2 clicks away from getting to Gitter. Okay. So any other comments or questions to Michiel? If not, thank you. And it's actually very, very, very nice to see this through the interface. I would like to emphasize once again, it helps people to visualize what this is about. So let's move on. So the next speaker is Hugo, who will update us on the status of OSIS.
Can you see my screen?
Yes, we can. Yes, it's all good.
Okay, so let's start. I will definitely be more brief than Michel because he did most of the work. So I will tell you a little bit what is the current status for the uncloud integration. So just to set the focus for this talk, what we are talking here is about the integration between the FSS with other elements, and these elements are applications and storage systems, and all these are wired through CS3 APIs. So let's see what are the different integration alternatives that we have for uncloud. So as you probably have seen, already heard, uncloud is launching a new product, the uncloud infinite scale OSIS, and as well we have the classical uncloud 10, which I think there was even recent release this week. So these are the two worlds that we have to face for the integration in the federation. So regarding the classical interface, as Michiel explained, we are doing a backport of the Nextcloud application to uncloud. Many of the functionalities are shared between the two platforms. So we expect to have a fully functioning application by the end of March. So this is something, some UI which already have in place for the uncloud integration. So as a system administrator, you will go to your instance. Either you will fetch the application by the marketplace, or you will deploy the application locally from the sources. You will enable the CS3MESH application, and then you will be able to provide some information like country, URL, and other metrics for the for joining the federation. Regarding the uncloud infinite scale, so this integration mode is different compared to the Nextcloud one, because the way that OSIS embeds Riva is not as a middleware component, but as a direct dependency. And this is possible because both platforms share the same programming languages. So this is basically just a dependency, a software dependency in it. So OSIS has with built-in support for the interoperability platform. So basically, if you deploy OSIS, you are deploying the IOP. And in theory, the only thing that you need to do is to configure some services to join the mesh. Today, we have demonstrated that we can collaborate across other sites using the CLI. And the next step for the OSIS integration is to also engage with uncloud to have the invitation workflow natively implemented into the OSIS frontend. And as you probably seen, uncloud is now reworking the user interface. So after this rework is done, we'll discuss with them what will be the best way to include this workflow that Michiel presented as well into the new uncloud OSIS. And that's basically it. There are some documentation about how to use the joint designs mesh from uncloud, but however, this documentation is work in progress as we are backporting the application and working on recent changes in OSIS as well. So just be careful with the information that you have there, and always use the channels in Jitter if you have some problems during the deployment. And that's basically it from my side.
Okay, thank you, Hugo. Any questions to Hugo? I actually have a question to both of you, Michiel and Hugo. So these UI elements that Michiel presented and that Hugo also plans to have in OSIS, are these somehow modular components that you can essentially add to the core system, or do you have to go on a fork of the platform?
Who wants to answer first? I can answer from the OSIS perspective.
Yes.
This is the one I know best. From the OSIS perspective, in principle, the frontend should give extension point, and that's the direction we want to take, to extend the user interface in the sidebar or with an icon to provide this invitation workflow. But this will need to take it on board with the uncloud team to see what are the possibilities there.
Yeah, in case of Nextcloud and OC10, it's an app that you install. So the site administrator installs the app, and then all the users have this extra icon in their main menu. There are also some changes to allow for dynamic share providers. So at the moment, you still need to have a separate branch of Nextcloud. So you need to patch the Nextcloud core, but we're preparing that to hopefully get that merged into Nextcloud Master, and the same for OwnCloud PHP. And so then it would just enable these apps to register themselves as a share provider, and then it works out of the box.
Okay, thank you. Klaas.
Yes, I just want to second Hugo and say that I'm pretty sure that we will find a way to have that in OSIS also as an extension, and yeah, alongside with the core product.
And actually, one question on user. We still have 3 minutes according to schedule. So one question on. I didn't understand that correctly, or maybe I missed it. So Michiel, in your case, is there a share produced? There is a share produced, right? When you accept the OCM invitation.
No, when so step 1 is that somebody generates an invite token, and then step 2 is somebody accepted. That is currently it's in the UI, but that will move to the discovery platform. And then step 3 is that you go to a file, you say you want to share this with somebody, and you select the recipient. Then the share is created, and then Nextcloud tells Riva to tell the other Riva via OCM to create the share, and then the remote share is created as soon as it's accepted. So yeah, at the 3rd step, it's created.
Okay, but so essentially you are not, when you want to share via OCM, you are not going to the sharing interface like with a local user, but you go to this other app. Is that correct?
No, it's the same sharing interface. There are already different sources of the autocomplete when you type a username. So when you want to share with someone, you can pick a local username. You start typing and it appears as a search result, and then you can select a local user. Or if you type a full OCM address, user at host, then it would look up whether that is available in Open OCM if the site has Open OCM available, enabled, which I guess most ScienceMesh sites will not have. And so if you have any accepted invites over ScienceMesh, then it will autocomplete from those. But yeah, so there could be different sources of people you share with.
Okay, but that sounds great, because this essentially provides the native experience of sharing.
Yeah, exactly.
Yeah, that's the goal of this project, to make this this experience with ScienceMesh as smooth and as native as you have within your own local group of users in your institution or in your instance. Giuseppe.
Yes, indeed. Catching on that, it would be also interesting to see how other things that you could build on top of the share, like opening files in applications. I'm always on this topic because this is what I developed on the OSIS side, would work in the sense of being able to use, say, the Nextcloud UI to open a file in Collabora, but the file comes actually from a remote OCM share.
Yeah, so the way that works in OCM, and the way we also did it for OCM over ScienceMesh, is with a WebDev mount. So the file appears in your in a folder, but when you click it, it does a WebDev request to fetch it remotely. So it's remotely mounted via WebDev.
Okay, which means that then the user will use the local system, the local application, etc., from a remote mounted storage.
Yeah. Well, yeah. So the user uses their own local user interface, and then some files they see are local, and others are mounted from somewhere else.
Remote.
Yeah.
Yeah. Thanks.
Okay, great. So if you have more questions, there will be time perhaps a bit later, or we can connect later. Okay, let's move on. So Maciej will tell us what's planned for C-File. So Maciej.
Okay, hello guys, can you hear me?
Yes, we can hear you, can see you.
Okay, and can you see my screen? I'm in the presentation, in fact.
Yes.
Okay, so I'll provide a short update on the plans on and the status on the CS3MESH to C file integration. Actually, the need for integration is quite obvious, but for those who could have some doubts, let's mention using also the information shared by Jonathan on Monday that there are several sites using C file in Europe and also across the globe. PSNC is representing C files community in CS3MESH project, but it's definitely not the only site. We're running the service since 6 years, having some powerful users storing up to even 50 to 100 terabytes of data. But the other sites are even bigger. 3 sites in Germany, which I mentioned here, are hosting several thousands of users each. So definitely we should take care of this community also by including C-file as a technological option for and a technological solution compatible with the CS3MESH. So, in fact, while having these users and beside the motivation for choosing C-file, which was mostly the reliability, performance, and so on, we cannot, of course, accept the isolation of these users out of the federation, which is being built. So the work has proper positioning. This work has proper positioning within the CS3MESH project. We've got a dedicated task for implementing integration with EFSS systems, including C-file. Currently, we're mostly in the discussion phase in collaboration between PSNC and Humboldt University Berlin. We hope to involve more people, more sites of C-file. Main body of work on the EFSS C-file integration will be implemented within 2022 with a plan, ambition, and hope to have the working prototype until the end of the year. For now, we are mostly planning the scope and the depth of the integration. I will come back to this later. And we're organizing the team, including already those 2 partners which I mentioned, so PSNC and Humboldt University, and also we're speaking to DataMate in C-file on their scope of involvement in this integration, and we're open for universities or other sites who are running C-file for collaboration. One of the basic planned steps is start simple by testing the Ocm compatibility, which was announced in C-file version 8 already. We had an update on it during the C4S update on version 9 on Monday. We've got already a tooling thanks to Michel's from PonderSource work, which was presented on Monday by him. And so these are the very basic steps to see where we are. What's the scope of the actual compatibility? We also know that C-file should speak with Nextcloud seamlessly, and this is also a thing which we will for sure test in the first steps. On the integration options, the let's say scope and depth I mentioned in the previous slide, we have to consider different approaches. Some background information which might be important to kind of understand this topic is that in case of C-file, the internal data organization is a bit different than in OCloud or Nextcloud. So data is organized in the libraries, as some of you know. They are kind of similar in structure to the Git repositories on the server side. So there's no one-to-one mapping of the files which are perceived by users to the files which are stored on the storage backend, which causes some complications when you want to implement some extra features, or additional to sync and share. On the other hand, the good thing about the architecture of C-file, which we'd like to use, is that it's quite modular. So all the clients, including the web interface, are implemented using the C-file web API. This web API is very extensive. It's well documented, and it's a public documentation. And coming back to the question we had in Monday, while the server itself is not open source, the documentation for the server API is very, very extensive and open. So it allows the seamless integration of functionality which we would like to have with the C-file code. Of course, there might be some hooks needed into the code, but this is actually the matter of discussion we are having now. Another thing is that we have seen examples of developing the interface, the web interface hooks. I will show some example based on MPDL work later, and this is also the place where we could actually hook our work. Concerning the deep versus lightweight integration, one option is that we heavily involve CFL limited into the work, and then we will be able to possibly, when needed, implement the extensions which are needed in the server side to be able to go from the OCM support towards the broader CS3 API support. The good thing is that OCM support is already there, so there is a good basis and also understanding on the CFL side or on the basic federation features. However, as you know, CS3MESH assumes also the application level functionality and some extra functionalities, invitation workflows and so on. So this has to be examined and discussed, and the level of involvement of CFL here will be like high in case you would like to make these things internal functionality of C-file. Another approach, a lightweight integration, I called it lightweight integration, is to develop some kind of proxy or overlay functionality on top of the C-file API with limited intervention into the C-file code, server code, and then possibly having a bit faster development track. But there are, of course, constant pros of such an approach as a duplication of work, possible duplication of work, or other issues. So possibly we will, in fact, implement the two-step approach, which would be fast prototyping using the lightweight integration approach, and then porting this results to the C-file server code. We hope to have a successful discussion with C-file, and also to push some items into the today's roadmap of C-file, which you could see also during the Monday presentation of Jonathan. So examples of web interface hooks. As you may imagine, you would like to want, on the basic feature side, we would like to be able to present the data shared to the federation. For now, you can see how the actual presentation of the different types of shares is done in the current version. We can see my libraries shared with me, shared with all, shared with groups. This is the current state. What we would like to add here is, of course, the presentation of data shared over the federation somehow is distinguished or not. This is a matter of discussion from the regular shares made locally using only C-file functionality. So the good thing is that we know that, and we've seen examples of successful extensions of GUI interface made actually by the end users, not that much by C-file. So this is example of it, and it also is important in the context of the applications you would like to integrate within the CS3MESH project. The pictures on the right side I borrowed from the Keeper project documentation. Keeper is a project for reliable and safe long-term data storage and archivization, archival, led by actually implemented by Max Planck Digital Library in Munich. And during this project, there were several extensions to the context menus done in order to enable users to trigger functionality such as, for instance, archiving the data or assigning DOIs to the digital objects or other stuff. So for full documentation, you can use the links which I put to the presentation. And we are considering other ways of reusing the existing work, such as, for instance, for the data science environments. We are trying to let's say test and examine the results of the Human Brain project, which use C-file on top of, Jupyter Labs on top of C-file, and other initiatives. On the other use cases, such as massive data transfer, which is part of the set of applications within CS3MESH4EOSC. We have a local driver at PSNC to implement this functionality, enabling people to transfer data from and to C-file to the other large-scale systems we have at PSNC and in national resources at PSNC in Poland, but also as a part of collaboration of PSNC, SURF, and Julish within the LOFER project. Okay, finishing up. The work is ongoing. We hope to involve you as a partners. There are contacts to me and Karsten. Please contact us by email. And we also planning to run the periodic technical telco starting in March this year. So stay tuned and please connect to us. We hope that we can have a benefit of civil community being connected to the mesh, in fact. Thank you.
Okay, thank you, Maciej. Very good to see all this research and plans being now quite concrete. I think we are a bit over time, so maybe we can keep questions for later.
Yeah. I'll be in the room for questions,
yeah.
if you like.
But I think it's definitely very important that we integrate the CFAR community. It's a sizable community in Europe. So it is really a good direction here. Okay, let's move on. Hugo, couple of words about how to development and technical engagement. Could
yes,
you brief us?
I need someone to unshare. Okay, good. So let me share the screen. I will go faster through it because we are a little bit outside of a schedule. So yeah, my name is Hugo and I am the work package leader, the technical work package in CS3MESH. So I will give you a quick introduction of if you want to contribute, how you can do so. So first of all, we work on very different and various technologies from basically API and protocol design with different technologies like gRPC, protocol buffer, OpenREST, etc. We also do CI, CD on GitHub Actions, Drone. We do software development in many languages because we develop extensions that can be hooked basically from client libraries in different applications. And we also do DevOps, especially on the monitoring and insights part. So these are some of the technologies that we use. So if you are keen on helping on any of these topics, reach to us and we'll be happily give you some tasks so you can help us to basically improve the mesh. These are the two organizations where we are most active. The first one is the CS3MESH, where we create all the artifacts which are needed for the federation. And the other organization is the CS3 organization, where most of the components that we rely on, like Riva, for example, and the Whoopi server, they are under this organization. So we are active contributors of this as well. Typical way to contribute. Discuss in an issue beforehand, then you can create your fork, create a pull request. So we will basically discuss the scope of the work that you would like to help. And after the discussion, we will basically merge the review. We have an acceptance rate of merge requests about 80%. So we are quite keen on anything that comes basically into the project. Then on the different, let's say, logistical areas where you can help on the vendors integrations that we have showcased today. But there are also other applications that were shown during the conference. For example, if you want to connect the Jupyter Hub to FFSS platforms, there is the CS3 API for Lab plugin to connect to Jupyter Hub. So the code is open source as well. So feel free also to reach out there to help us develop in this connector. And also for the backbone, you can also help designing the CS3 APIs for some of the areas. Currently, we're focusing on the locking part and also on the Riva server for optimizing it or adding new services which may be needed in the future. We have basically a way to develop where we really rely on the CS3 APIs. So once we have the definition, we can generate different bindings for different programming languages, so you can basically use it as a client from different places. Regarding the CI and CD, we have an open platform also for running the test, so you can easily go there to Drone and see basically the latest status of the PRs and the merges. Also with thanks to Uncloud, who contributed a lot for the testing, we also revamped the testing framework. So we basically added a lot of tests which are kindly contributed by Uncloud. So now we are more confident about the development of new features that we may break existing workflows. As I said, the definitions of the APIs are defined in the CS3 APIs repository, and then the bindings are automatically generated. So here you have 3 examples: the Python, the JavaScript ones, and the Go ones. And as well, what we do after these bindings are generated, we also push them to the respective package managers. So if you type, for example, CS3 APIs in NPM, you will have basically a dependency that you can add in your manifest.json file, and it will automatically be pulled. Same for Python in PyPy, and in Go, we basically just rely on the default package manager. All the artifacts for ScienceMesh, they are based on Kubernetes charts. We have 3 charts. One is the IOP, the other the central brain, and the other are the mesh apps. In this talk, I'm focusing on the IOP, which is the most important component, the one that brings interoperability into mind. The central brain is a chart that brings many supporting services like Prometheus, Grafana, and other central databases to ensure a healthy participation into the federation. And last and not least, we have also the mesh apps Kubernetes charts, which adds applications on top of your deployment, like CodeMD, Etherpad, Collabora, etc. So regarding the IOP, the best way to deep dive into it is to go to the documentation. So it was already pointed out in many of the presentations. So go to it, and you have questions you can also ask in the digital channels. So the IOP is this middleware component, this big blue ball that sits in the middle, and it contains the Riva server, but also like the Whoopi server for the applications and the Arclon for data transfers. And the way you deploy it, if you have a Kubernetes cluster, is just with one command, and if you run on a standalone integration, you will have to download the binary and create the configuration files manually. We look into the future if we provide also like packages, for example, for RPM and other operating systems. So yeah, basically the IOP is based on Riva, which is a web HTTP and gRPC server. It's written in Go. It implements various interoperability APIs, mostly CS3 APIs, OCM, and WebDAV, and it provides different extension points for new storages, authentication mechanism, and applications. So in principle, we can basically add any service which can speak HTTP or gRPC. So as I said before, here are 2 links where you can find help on this core technology. Documentation is being reworked to make it more clear to the users and to also provide some how-to tutorials. And this is our Jitter channel where we are quite active on it. So feel free to hang out if you need some questions. And that's it from my side.
Okay, thank you very much, Hugo. If there are any questions, please put them in the chat of the Zoom chat, or reach out on Gitter, actually, maybe even directly if you want. I think we have to move on. So far we've discussed and presented the core fabric, but ScienceMesh is more, and that more is various applications and workflows which are implemented. And Holger will give us a quick recap of different applications and user communities that are testing them. So Holger, please.
Yeah, thanks, Kuba. As he said, we heard by now a lot about ScienceMesh and its core and the backend and how to join, but I want to bring you ScienceMesh now closer from user's perspective. So what's the benefit for a user using your EFSS if you join ScienceMesh? And yeah, just for the introduction, you know all what this is, but it is also about integrating open data and open source tools. And these tools I now want to speak about. But before we start with that, let's have a look in our user communities. So who are our users and what are they doing? And therefore we try to analyze what are their needs. So one example user community is the high energy physics community. And what makes them special is their tremendous amount of data they produce. So at LHC, you see there are hundreds of terabytes produced per day, at least even per second, and stored not incomplete, but yeah, you see there are a tremendous amount of data, and therefore moving those data around creates huge problems. And therefore you need to come up with solutions that comes to the data so that you do not need to move the data to the computing power, but the other way around. Another use case where this is also the case is Earth observation. Imagine you have satellite data in high resolution, for example, here from Northern Africa, and you are analyzing land degradation. And this might also be a use case where the amount of data is too big to move them around quickly. And therefore you have to have something in your EFSS to make the analyzation of your data possible. Next community was, I wouldn't say special needs, but additional needs here is the RISE SMA project. They are distributed all around the globe, and therefore we have here maybe distributed systems, so users sitting at different EFSSs with the need to interconnect, and they all have to have access to the data. And also what's special here is that they are working with different types of data. So they don't only not only have, let's say, Office documents, but also different types of documents. And probably to streamline the workflows, they want to work with those different types of documents inside the EFSS, meaning in the browser. Another use case, and here we spoiler also our solution for that, is LOFA. This is radio astronomy, originated in the Netherlands, so working closely with SURF. But to get the data into SURF, they need a mechanism for data transfer. So in comparison to LHC, this is a bit different. Here we, in fact, are trying to come up with a solution to move the data to and out of the EFSS system, and we also have to keep this in mind. To make this a bit more general, what could we think of use cases from our user communities? This is for, of course, cross-border data sharing. So sharing data is probably possible and necessary in all those projects, but also having more streamlined workflows. And I mean with this, that we want to make a tighter integration of different tools into the EFSS to make it easier to enrich your data with metadata and therefore reuse once entered metadata. We need intuitive and easy to use interfaces for data transfer, and also the capability of doing computations with data stored in your EFSS system, but also the possibility to push those data, if they become too big for your computational power, to HPC clusters. And also not pushing data to other users, not only to, let's say clusters, but also to users from other EFSSs. And last but not least, the possibility to directly edit files that are stored inside of your EFSS, being this Office-like data, so to edit them with non-MS Office editors, so we're integrating open source solutions here, or maybe graphics or other types of data. And all in all, we are thinking about having most researchers a workflow like this. So they come up with a planning phase for their projects, then are collecting data, maybe moving them around, doing the computational stuff for analyzing their data. And if they come up with great results, they will create publications and publish their data to open source scientific repositories. And after that, we are not done. To have fair data, you need to preserve your data and push your results to some kind of archive. And for all these steps, some components in ScienceMesh might help the researchers. So we distributed those work in 4 different tasks. That's not really important to keep in mind for you, but just as an information. And I want to go quickly now through these tasks. we have the Jupyter Lab integration, meaning that we are making it possible to use in-browser computation on your data. As mentioned before, this might be interesting for different user communities. Here you see it for the high-energy physics community, to be able not to copy your data first, but just reuse your on-site Jupyter Lab with your own data. The next one is a bit more complex in terms of explaining what happens here. With open data systems, we are creating a middleware that stems originally from a joint from another project, this being Skibo RDS. It is the middleware that creates connectors from the EFSS on the one side to different services on the other side. And these are connectors to push data from the one side to the other side. So let's remember the publication step. So you created a publication and want to now push it to Zenodo. Then this is possible with this RDS backend here. There is currently at least a separate app in the EFSS systems where you can call a metadata editor, enter your data. So who are you, who are your colleagues, and what is written in this publication. And then the RDS core takes these metadata and pushes them with your PDF, for example, to Zenodo. And the good thing here is that it's rather easy to create even more connectors. So I put a bring your own connector here to the slide because this is of course all open source, and it's possible and intended that you, if you're using ScienceMesh, are enriching this middleware by your own connectors to create even more interest in this list on the right-hand side here. Next are document editors. We have CodeMD integration and Collabora integration. Since I'm running out of time, I'm not going into details here. And we can also integrate OnlyOffice. All this, we are using the WOPI interface that was earlier mentioned. So the good thing is, if there is any other solution using WOPI, it can probably be rather easy integrated into the existing solution, and therefore should make document editing even more easier and more versatile. The on-demand data transfer is done with two different tools. It's a bit depending on the size of the data to be transferred. We have on the one side Arclone, the Swiss Army knife of data transfer, which can connect to a huge bunch of cloud services. It's for small and medium-sized data, for ad hoc data transfer. But if the data becomes too large, it might be better to do this in a managed way with a tool called Ruscio that's also been integrated. And on my last slide here, I have a sketch how Ruscio works. And since I'm not the expert here, I'm not going to explain every step here. But as a resume, I can state that, with those tools, pushing data to and from other services should be rather doable. And with this, I come to the end from my presentation. Thank you for listening.
Hello, Holger. So thank you very much for this. So are there any reactions from the audience? Anybody would like to ask anything? I think one important aspect to highlight is that essentially these different user communities that you mentioned, they're also the pilot communities. So all this functionality is currently being tested or is being planned to be tested with the real end users in these communities. But I guess also the system is modular enough to if in case some new applications or user communities are identified, either to reuse the existing components or perhaps contribute to developing some new ones. Okay, so perhaps we can move on with our program. So thank you, Holger, again. So now we will change the subject slightly. So I think we will go away from the technical topics more into the more broader view on the challenges in the fair data infrastructures and the science mesh, how it can be done, how can be used for advantage of the scientists and researchers. And I would like to invite Gozal, who's been doing a research on this topic and running some questionnaires, and she would give us her perspective on this. So Gozal, please.
Thank you so much. So can you see my screen?
Yes, and we can see your slides too.
Okay, perfect. Then thank you so much, everybody, for taking time to attend this talk. And as already mentioned, this talk is slightly different, but again, we are focusing on, as Holger mentioned, more on user, but what we are doing here is to framing science mesh as a source of advantage for the researchers. So this research work has been developed by Angelo Ramasanta, Jonathan Warham, and me, Gozal. We are from ESADE Business School, and we are actively studying commercialization of science and the innovation systems and ecosystems. That's why we are really interested in this project. And our aim is to, well, as you know, Science Mesh we are surrounded in Science Mesh with domain experts, leading domain experts in technology development and cloud storage. But what we think that good technology solution cannot solely meet the market demands. That's why ESADE here complements the technical aspect by exploring commercial side of the Science Mesh, and that's why our aim is to find out what's the business impact of this project, and report also challenges and guidelines for collaborative user communities. And also we explore social and economic institutional barriers in this infrastructure, in digital cloud infrastructures, and particularly in the mesh. Well, basically it's what we do. And in terms of current let's say progress, we have done conceptual review on open science and also the role of the mesh to address the fragmentation. And we presented it in last year in the European Conference on Information System, and it's indeed available for everyone that is interested. And also we are running currently and several interviews, and we have already some of them with key stakeholders such as academic community and the project team. And finally, we want to share the research progress that we have done on the bridging role of science mesh in fair data, and it was submitted this year to the European Conference on Information System. And today I want to share with you some of the results that we have found out. And basically in this study, what we ask is what's let's say how we can promote the adoption of fair data and open science infrastructures like science mesh. So for this, what we have done to conduct a qualitative study, mainly interviews with different, let's say, stakeholders of science mesh. First of all, we have interviewed with project partners, of course, and also with early adopters. But what we did is to include a third group, which is a scientific community that is not at all related to the science mesh and are not connected in any way to this type of infrastructure. So by including this third group, we want to understand their expectation and if whether this type of technologies met their needs and requirements. So what we find is that our first finding is that many individual scientists still don't understand the promise of fair data and the capacities that it can provide them. specifically, in fact, researchers mainly haven't heard about, let's say, about mesh and about science, about this open science, and their perception maybe is a challenge that we have now, and we are trying to solve it. That their perception is mostly like, are there any values that we get from sharing our data? So what we do in ScienceMesh now is to interview people and to ask them how we can bring the value. And what we think is that mainly we are talking with the ScienceMesh community to find out these advantages and these unique perspectives to be then to be able to transmit it to the scientific communities that are not related. So as an implication of this study, we realize that we need to change our framing of how we sell science, how we sell open science and fair data. And as I told previously, the general message is that researchers should adopt this because it's good for them, because they can share their knowledge and to contribute to the collective benefit of the community and etc. In other words, what we focus is more on the personal aspect of the scientific, like is that person is generous enough to share the data. But now what we want to do is we should focus on the competitive side of researchers. So by adopting this kind of digital infrastructure, what we can bring them, how they can be more competitive enough, and what it means focusing on advantages that mesh offers. And that's why, focusing on this message, we have just come up with some preliminary advantages that we can offer. Is that first, researchers store their data and never look back again. So perhaps one of the use of the mesh and digital infrastructure like this is enable the researcher to reactivate their data and to be able to revisit them in a convenient manner. And also it enables them leverage their data and other users. Second, we also focus on the new ways that researchers can share and collaborate with data through the mesh. Previously, researchers that are not related to this community are, well, they're using the current alternatives, let's say existing infrastructures, like to name Dropbox or similar infrastructure, and they're not aware of the capabilities that they can have using the mesh. Already, the ScienceMesh team, they have mentioned the user perspective, and Holger have focused on this. So we want to identify these capabilities and to show that using this collaborative notebooks, remote data analysis, how they can gain a competitive advantage. So, but unfortunately, the most researchers haven't heard about it, and mostly they think about, when they think about cloud computing systems, they think about storing their data, just have a backup, or similar things. But what we want to do in ScienceMesh is to show these different capabilities. So that's why what our conclusion is that, well, before going to the conclusion, I want to mention another thing that is really very important that we have found, is that from our interviews, one strength, that potential strength, that how we can sell it, is that ScienceMesh is has all the relevant data, all the relevant tools, and plus people in one place. So one place, researchers can enter, log in one place where they have all the data-related processes as they need, and at the same time they have opportunity in one place to share the data with other people, with their colleagues, or with other scientific community. And so that's why, as a conclusion, is that we find that these infrastructures are they're developing, but there is a lot still to do with research adoption of the mesh. While it's good that we focus on the development of the technology, now we want to also, simultaneously, to focus on how we can sell this digital infrastructure as a advantage in the research. So for the next steps, and for this, we want to find out, first of all, we want to measure the readiness and ability to adopt fair data in the organizations. And also we are evaluating impacts of fair data in academia and in industry. But what we are planning is that we have done already some work, we have some progress, but we consider that there is still to cover we still need to cover different insights. So for that, we hope that we can interview more scientists from organizations as CERN, GRS, GRC, LOFAR, and this way, to be able to cover the different insights, we can get more robust and more valuable information that we can transmit to the researchers. So also, like yesterday and today, and we are going to talk about this, the governance issue. So we want also to contribute to the conversation of the developing sustainable governance for science mesh, and we are actually currently engaging in these activities, and we want to define key exploitable results and guide business plan development. And in line with this, we also want to conduct further studies to explore the best financing models for the mesh. So basically, it's our contribution today, and we really hope to know your opinion about it and your feedback, and how we can explore more and how we can do our these insights more useful for you, because we are interested also how we can improve it. So thank you so much.
Thank you, Gozal, for this very interesting presentation. I think many points you raised spot on, and very nice to see this analysis. And I would also agree that the analysis of the sustainability and commercial exploitation is something that probably would be very interesting for this for further uptake. And I think also we could, this is now my message to the audience, you could perhaps also take the presentation of Gozal as an invitation to connect to her. And if you have not yet participated in any science mesh activities, but you have a certain point of view of what your researchers needs, or what you think would be useful, this is also your opportunity to influence a little bit the roadmap of science mesh in general, and also to contribute some data to this analysis and to this study. So I think it's a great opportunity also for people that have not yet really connected to this study. I see Bob has a question. Bob, please.
Yeah, thanks very much. I thought it was very interesting to see that information. One other angle to consider is what could be the exploitation within the context of the European Open Science Cloud. There are a number of ways that we can look at that. Sort of you talk about the interviews. Can the different research communities, which are perhaps not engaged with science mesh at the moment, but are known through the European Open Science Cloud, could they be another source of these interviews and information which you could potentially make use of?
Thank you so much, Bob. We will consider it for the further studies. And thank you for Kuba for highlighting our invitation.
Actually, I have now a question to Bob after this. So do you know that if in some EOSC communities or some EOSC initiatives, there are some similar studies that are performed that could be maybe useful to get Gozal connected to some of those people, or maybe to some of the methodologies that they use, or some?
Yeah, there are a few things done in the previous executive board, some of the studies that were done there, working about the different communities for exploitation beyond strictly research and education. And there was the Industrial Commons organization that is taking that up, and they're a good opportunity to talk to them. The other thing is that at the moment there are 13 task forces going on and started operating at the moment, One of those is researcher engagement. And under that, they're looking at what are the motivations and so on, and what, in order for researchers to make use of EOSC, to participate and so on. So I think that could probably help the colleagues at ESAD to try and understand a little bit more what some of the driving elements are for researchers then.
Okay, that sounds very interesting. And actually all this topic bridges us very, very well to the second part, which will start after the coffee break, because in the second part we will hear actually from some of those task forces that are now working in the context of EOSC on different aspects: sustainability, long-term preservation, interoperability. And also we will hear in the second part after the break a panel discussion with some other research infrastructures that have not yet been let's say in the core of CS3 or in the core of ScienceMesh. So this will be also our opportunity to get some conversation with these communities, astrophysics, societies and social science and humanities, light source and experiments, and environmental studies. So I think this conversation with these new user communities and actually infrastructures will be also, I think, very pertinent, Gozal, to your study, and I also think very interesting for everybody here to listen to. So let's take a break until 4:15. So you have a 3 minutes bonus for the coffee, unless there's any urgent questions or reactions from the public. Anybody would like to say something? Okay, if not, let's meet again at 4:15, and we will have this second part, which I think will be very, very interesting as well. So thank you very much, and see you in a bit.
Well, good afternoon, everyone. I hope you're all back from your coffee and gathered down, if you were there. The next session that is called EOSC and ScienceMesh. Let's say we have 3 speakers in this session. One speaker is a board member of the EOSC Association. EOSC Association is the body that governs the European Open Science Cloud Initiative. The implementation of the Open Science Cloud Initiative is in the hands of the so-called advisory groups, which have task forces that are work on certain dedicated projects and topics. We have 2 members of those task forces here in the house for this afternoon. The first speaker I'd like to introduce is Professor Ignacio Blanquer. He will discuss about the goals of the EOSC Association and also plans that they have to advance open science in Europe. And we have 2 members of the task forces. That will be Pierre-Yves Bourgie and Roberto De Cosmo, who will give their insights on the priorities and the work that they are doing in these task forces, and also help us brainstorm in what these task forces are doing and what other infrastructures are delivering, and what the ScienceMesh is going to contribute to the Open Science Cloud, how this can be brought together. Well, let me give a first, let's say, introduce you, Professor Blanquer. Ignacio Blanquer is a professor of the Computer System Department at the UPV in Valencia since 1999. He has been a member of the research group on grid and high performance computing of the Institute of Instrumentation for Molecular Imaging. And he's also becoming the leader of this group and the vice director in 2019. He's also the coordinator of the Spanish network of eScience and serves as an expert to the Spanish Ministry of Science in the areas of eScience. So I'd now like to give the floor to Professor Blanquer.
Thank you very much, Ron, for your kind words. Thank you very much for this opportunity to present the EOSC Association in this forum. I hope that I will raise the attention and the interest for some of the points, and I think that they will be complemented by the task force's presentations of my colleagues. So please, next slide. Right, so let me first briefly, I mean, I know that many of you already are quite aware of the concept of EOSC, just let me rephrase a bit and explain a bit which were the origin of all these initiatives. So we start from 2016, so long ago, with the high-level expert group on EOSC that set up and defined some principles for the implementation, which has been carried out intensively by a set of infra-EOS projects that in which some of them I will concentrate also on the creation of some working groups from the EOSC Executive Board, which managed the launch of the European Open Science Cloud by the end of 2018, and the creation of the association by middle 2020. The association entered in full work during 2021, and with the setup of the task forces by the very end. So EOSC, as you know, is a virtual environment for open access to services, stores, share, process, and reuse research data. It has been intensively funded by different initiatives and also currently destination too. So next slide. So an important effort that has been done towards the creation of the definition of the model of the EOSC was the working groups of the EOSC Executive Board that were created in the frame of the EOSC Secretariat project. In these 6 working groups, they were addressing different aspects like landscape, with an inventory in relation to multiple dimensions of EOSC, FAIR, architecture, rules of participation, skills, training, sustainability, and many of them have an important relation with the topic of this workshop, like the word of the FAIR, with the FAIR practices for data, and the part, especially the working groups on the architecture, in which the interoperability framework report was defined, some report on the architecture blueprint also prepared, created, and also on a scholarship infrastructure for research software defined. Again, also it's important also to state that in the skills and training also there was a lot of effort on defining the research software engineer and data science role in the EOSC. So next slide, please. So how is EOSC managed? So EOSC is managed, or the implementation is guided through a tripartite model. In this model we have the European Union represented by the European Commission, the community represented by the EOSC Association, and the countries represented by the steering board that was set up on 2021 and is acting as a national-based body to drive the implementation and coordination of national policies. So association is an important part of this government part and represent the community. So the association basically, if you go to next slide, please, is now currently formed by more than 230 members, 233 members, participants, partners, I would say. 2/3 of them are full members with both rights and also the capability to elect and propose members for the presidency and the direction, and 73 observers. So most of them come from research performing organizations, but also a service providing organization has an important part of the share. So next slide. Yeah, so the implementation guideline is defined in that is called the Strategic Research and Innovation Agenda, which is a document that is linked to the slides that you have available, in which all the objectives, all the KPIs or the plans or the activities are extensively defined for a long period of execution. So let me state 3 of the general objectives, or the 3 general objectives, which are to ensure that open science principles are are becoming the new normal, to enable the definition of standards, and especially relevant for this workshop, the establishment of a sustainable and federated infrastructure to enable the open sharing of scientific results. So next slide. Along with these general objectives, we have several specific objectives that are very critical for the success factors. And there, I try to outline 3 of them that again have a lot of relation with this workshop, which are the specific of the objective 5, the EOC interoperability framework definition for fair digital objects, including data and software and other research artifacts. The specific object 6, providing an increased number of services and resources to make the concept of EOS viable, and the number 7, which is the definition and the operationalization of a stable and valuable infrastructure. So next slide. Along and also, there are several operational objectives, and I just outlined 3 of them, which are of crucial interest for our group. So we have the minimal viable EOSC definition by 2025, the technical components of a fair ecosystem uptake and customization, and the co-development of a first generation of a pan-European network of infrastructure for software source code by 2025 again. So as you see, there are real tangible actions that they are planning to be executed. So next slide. Yeah, how we want to define all these or coordinate all the activities. So we set up a set of working groups, advisory groups, 5 advisory groups that are covering different areas of related to the implementation of EOC, that also complements the work that has been done in the expert boards of the executive board. So in this these 5 advisory groups in total define 13 task forces that address points like the technical challenges regarding the technical interoperability of data and services, infrastructure for quality research software, and other related to data interoperability like semantic interoperability, fair metrics, and long data preservation. So all these different task forces are liaised through a member of the board of directors in order to have some degree of coordination. So next slide. As you will see, the number of people that wanted to contribute has been huge. So we were really proud to see this commitment from the community. And finally, there was selected by the chairs of the task forces 450 applicants, right? Experts that relate to the different areas. So these representatives are meeting frequently in order to align their plans and try to provide some deliverables that will help on the implementation. You can see all the draft remits in the links there. So next slide. Yeah, among all these different task forces, I wanted to raise one of them that I know that Alvaro couldn't come, which is the one related to technical interoperability. This task force is focused on defining several standardization guidelines, several principles, architecture blueprints, definitions, guidelines, and recommendations in order to achieve the federation concept of connecting different research infrastructures and generic e-infrastructures. So in this case, this task force is coordinated by Álvaro López from CSIC in Spain and Eva Seaca from the INAF in Italy. So you can see the draft charted there that states that the objective is to take as basis this interoperability framework as recommendation and develop a technical architecture to develop this EOC core and exchange set of services. So the task forces are not developing services, but are providing guidelines. So it has 4 subgroups dedicated to 4 areas: landscape, data technical interoperability, service technical interoperability, and technical architecture recommendations, and plans to release 5 deliverables, 4 deliverables, and 1 with a revision, addressing all these different definition examples, blueprints, and recommendations. So next slide. Just to end, so I want to say that EOC aims at fostering the development of open science by enriching publication data and software according to FAIR principles, according to federation, according to different approaches to make them usable for machines and scientists and get more rewarded research. And through the task forces, we believe that we will be able to coordinate the development of all and the gathering all the knowledge that is needed to create this and to guide the development of these assets. If you want to get more information, you have the points there. So thank you very much again. I will be at your disposal for questions later on.
Okay, well, thank you very much. The next speaker in this session, that will be Pierre-Yves Bourgie from University of Geneva. He has a PhD in computer science. At the moment, he is the head of the Information, Communication and Educational Technologies unit from University of Geneva. And he is also a member of the long-term data preservation task force. Pierre, the floor is yours.
Thank you, Juan. Good afternoon. So indeed, I will explain a little bit what we are doing with this long-term data preservation task force, which started 3 months ago. Next slide, please. Thank you. So what is the aim of this task force? It's really providing a recommendation for the EOSC board, as we understood before. But this is for the thematic of the implementation of long-term data preservation policies and practices. We also want to make some suggestions on the strategy execution, and also addressing the roles and responsibilities of the different stakeholders. Also the financial aspects, which is very important for long-term preservation, and the necessary infrastructure. And next slide, please. So who are we? This task force is composed of 36 members from 16 countries. And here I show the distribution of the different institutions which are involved in this task force. So mainly is from service providing organizations. I give some examples, it's not exhaustive here. And of course, this classification is not exclusive. If I take my case, for instance, I'm from the University of Geneva, so I would be more like a research community, but also I represent Holos.Swiss, which is a national service for long-term preservation. And so this is clearly a service providing organization. Next slide, please. So because we have a lot of thematics to address, we organized in subgroups. And so the task force has 2 co-chairs, and each subgroup has a coordinator. And here you see the 4 subgroups, which I'm going to describe now, all of them. Next slide, please. So the first one is about shared understanding and vision. This is very important to speak the same language. What we already with the kickoff meeting we had already in this task force on other meetings, what we could observe is that even within our community of experts in long-term preservation, we didn't agree all the time on the terminology. So of course, this is very important, not only within our task force to understand each other, but also to define clearly what we mean by digital preservation. And also we want to map the broad long-term data preservation landscape, which is quite heterogeneous. And you find different maturity levels in this domain, and with a lot of stakeholders. So we want to provide suggestions, policies and strategies for the retention and curation. Curation is very important, of course, and it's whole field. how to collaborate and create synergies. But risk analysis, it is an important risk to be hacked, especially for long-term preservation. So we have to be very careful. So the expected output from this group is recommendation of the vision on sustainable implementation of long-term data preservation policies and practices, and suggestion for strategy execution. Next slide, please. Next slide. Thank you. Financial aspect. As I said before, this is a very important question, and you have to question the value of data because it costs a lot of money to preserve them, including the indirect cost like carbon footprint, for instance. And we want also to identify business cases, which is of course very important as well to get the right way to manage financially this infrastructure. So the expected output is a mapping of the financial aspects of long-term data preservation, including the financial responsibilities of the different stakeholders, and also mapping these different business models. Next slide, please. Trusted repositories. So we have to establish an inventory of the operating European repositories. So there are already a few of them. And we have to see also to assess those which are already certified or will be certified by 2025, which is a requirement of EOSC to be operated. So expected output is recommendation on the creation of this European network of this trustworthy digital repository. One important aspect is that they have to be fair, F-A-I-R. We have to give a recommendation for EOSC about data services connected to this network, and also establish a roadmap to further mature the long-term preservation aspect of these repository services. Next slide. How do we proceed for this work and this how we work in these different groups? First, we do desk research to identify reports. So we are in the first phase reading a lot of papers, reports. We are going to have open consultation with webinar workshops. And then we will revise recommendation based on decision-making and consensus, so that we really have an open discussion between us to get this consensus. The planned duration of this task force is 24 months, so it should be finished by December 2023. Next slide. And of course, we are not alone, and so we have to create synergies with other task forces, which are listed here. And there are quite a few with which we have to collaborate, because we have a lot of aspects which are shared between these different task forces. Next slide, please. And yes, if you want to know more about this task force, you have the link here. Thank you.
Oh, thank you very much, Pierre-Yves. So our next speaker, that will be Roberto De Cosmo. He's a director at the Software Heritage Project. And he is also a member of the Infrastructure for Quality Research Software. He was a professor of computer science at the University Paris Diderot, and currently is on leave to head the Software Heritage Project. Roberto.
Okay, thanks a lot. Can you hear me? Does it work? I hope so.
Yes. Yeah.
Perfectly. Yep. Okay. Fantastic. Okay. Thanks for having me with you here today. So I prepared some slides to give a little bit of a presentation of where the task force on infrastructure for quality research software comes from and what it is planning to do. So if you can move to the next slide. So a little bit of background. Over a year ago, during the initial phase of the preparation of the EOSC that Ignacio Blanquer already presented to you, there was a working group that was dedicated to analyzing the landscape and the needs and what is a roadmap for scholarly infrastructure for research software. And so the focus there was precisely on source code and not on every possible virtual machine or executable that you can imagine, and in particular on the issue of archiving, referencing, describing, and giving credit to authors for software source code. This task force brought together actually representatives from a broad variety of different actors in this space that already work in this area. So by the way, since we are hosted by CERN, you will be happy to know that Zenodo was part of this group. And then you have HAL, which was a national open access archive in France, Software Azure, which is the organization I lead, which is creating the Universal Software Archive. Then you have publishers and aggregators, etc. This is a huge report that I do suggest you to have a look at. It is almost 100 pages with a lot of real precise workflow requirements, state of the art, etc. And if you can move to the next slide, please. To sum it up, I mean, it's kind of complicated to sum up the 100 pages, but let me give you a big picture. So overall, what we understood is that there is a general architecture of this infrastructure that support software in the scholarly world. I mean, you have a part which is a scholarly ecosystem where you find scholarly repositories like Zenodo or HAL or many others. You find publishers, you find aggregators like OpenAir or other places similar. And this ecosystem is just one part of the world around software. Then you have other ecosystems. You have an industry ecosystem, a public administration ecosystem, a cultural heritage ecosystem, because as you know, I mean, software is really pervasive. And so it is important to build our common infrastructure using a common layer, which is provided by a universal software archive. It doesn't archive just research software, but also all the other parts. And so the main challenges identified is how to actually ensure long-term archiving for the different layers, I mean, the source code and then the extra information that comes in the scholarly ecosystems, I mean, specific metadata and citation information, etc. How to ensure global referencing, having descriptions which are interoperable, how to find a way of crediting authors properly. So in the report, you see a bunch of actionable recommendations. So one, of course, is to bring more often and better together people working for archive, for publisher, and for aggregators. Try to focus on a common metadata standards. You all know the ITSCA CD about the 13 standard that become 14. Okay, so try to avoid that. So for example, there is one which is called Meta that seems to have some consensus behind it. Try to focus on it. Organize the identification of software artifacts at the different layers. So use intrinsic identifier for the source code and extrinsic identifiers for the higher levels and project names, teams, etc. Support proper citation, etc., etc. So that was kind of well defined, right? It's a report which is state of the art. Out of this, and together with other issues, came the idea of creating this task force. We can move to the next slide because now the background I think is well established. Next slide, please. Again, thanks. Wait. Back, no, forward one step. Thanks, just there. So the new game in town is this infrastructure for quality research software that I have the pleasure to co-chair with Isa del Campos. You have a draft charter which is available. I mean, click just on the blue thing in the slides that will be shared, you will get there. And so the objectives here is actually multiple. On one side is to take the recommendation from this CEOSC report, which is contains a lot of work, and try to actually work to implement them by fostering development and deployment of the kind of tools that are needed for archiving, reference describing, and sharing research software. But there are new issues that come too. One is the quality of the software that we are looking at. How can we support better quality? In particular for software and services that are offered through the EOSC, but the issue is more general, so there is a group working on that in particular. And also another issue, which is how to increase actually recognition of the work done by software developers and maintainers to bring it to a par with what happens with publication and data. So I do not know where country you come from, but I mean, the situation is very uneven. It is not the same if you're in France or in Germany or in Italy or in Spain. There are places where actually software development in academia counts for 0, and this must change. So let's move to the next slide. In this slide, you see how we design the core activities for this task force. Of course, we need to connect to what exists. The software is huge. It is not just in research. You need to have a landscaping effort. Then there is, of course, as I mentioned before, this SEERS report implementation. I mean, there the plan is already clear, and we need to disseminate it and collaborate with projects that actually implement it. And then work on issues like quality and sustainability. And there are some transversal issues like what we do about career development, education, and training. Okay, the plan is not of doing everything, okay, but it's just to provide guidance, provide suggestions in the framework of the EOSC to address all these issues. Next slide. You see the task force actually attracted a lot of interest. So we have 41 members for 17 different countries in different roles, and it goes from research engineers to full professors to lead organizations. I mean, really a broad range of expertise that comes in. And then if we can move to the next slide, you will see I copied the presentation from the previous presentation. Thanks a lot. So again, it is organizing co-chairs with a bunch of subgroups, and there is a typo. Well, okay. In the subgroups, there is one which is dedicated to the software life cycle. So there we try to understand better, I mean, this issue related to quality, sustainability, etc., etc. Another on the information science perspective, and this is exactly the implementation of this SEERS report. And the last one, which is not software life cycle, the title is actually ensuring quality software. This is for seeing how to measure and improve software quality in general. So next slide here, the working group just started working. Next slide. Okay. And again, if you want to know more about, for example, who is in the working group, there is nothing secret, and the full list of participants is online on this web page. And I hope I could keep the 5 minutes. Thanks a lot. I will stop here.
Oh, thank you very much, Roberto. Then I'd like to ask the audience, are there any questions, remarks?
So maybe if we have a little bit of time.
Yes, we have.
So thank you very much for these very interesting presentations. I am Kuba Mościcki. I'm the coordinator of the CS3MESH4EOSC project, and I'm from CERN. And I actually would like to. I think one of the, one of the interesting aspects of this discussion could be, we've been thinking a lot, how we can, what we can bring to EOSC as this community. Because we have a community of users, community of service providers, multidisciplinary one, including also the commercial software vendors, all based on open source, but including commercial software vendors. And also we have many elements, that you have mentioned. For example. In this community, we have initiatives already and discussions already for many years on interoperability between these different services, because this is an essential, is essentially the essential component. And actually, what we are trying to build is a science mesh is based on all those technical elements and all those actually running and deploying systems. Deployed systems by essentially ensuring that there is a interoperability between them, and thus creating a kind of a federated environment which works seamlessly for all the users, no matter which particular technology they use or particular EFSS platform. for what concerns long-term preservation, we have one of our application workflows to which the ScienceMesh users have access is the connection to the digital to the open data repositories. Obviously Zenodo, but also more broadly other repositories, Invenio RDM-based repositories, for example. And I think about the quality infrastructure, we also have a topic in common here, because as a part of our federated infrastructure, we monitor the quality of it essentially as well. We have monitoring metrics. We do have testing, so to ensure that the entire operational status is known, understood, and under control. And we've been discussing for a long time in the project, but also in this wider CS3 community. Here we have also in the audience many people who are from the broader CS3 community. How we can bring some added value to EOSC, and also how EOSC can help us to get some added value from itself. So I don't know. It's just an open question. I don't know. It's nothing really specific, but I think it's probably something that I guess many people in the audience are asking themselves.
Okay. Maybe if I can take this, Jakub, thank you for the question. Thank you for the comment. I mean, first, start saying that the association by itself, the task forces, are not implementing directly, are not the driving forces. I mean, there is the projects, right? And the way that we could help is providing the framework for this coordination to happen, and also to break the silos of the individual projects, to see and to facilitate this community, right? So the task forces were a nice instrument in order to create a set of a team of experts. And I believe that there are many task forces in which the experts are not, involved in some of the projects that are running out. I mean, there are new projects that are coming, and we are defining the way how to interact with the project, but for sure that will be crucial. I think that it will be very important if the chairs of the different task forces make an analysis of the different, or we will do through the association also, of the different projects and analyze how they can we contribute in general. I mean, in the past, in the last implementation phase, I will say, of the Commission, there were very few meetings for consultation meetings of the project, right? And we have to break this and try to bring everybody together. And for sure, there are efforts in all the projects that have to be recognized and promoted.
Mm-hmm. Thank you. And can I just quickly ask something, Ron, before you hand over to Silvana? So,
okay, go ahead.
So I'm curious. So what is? So I understand that now the task forces are preparing a report, and actually many of us are involved in different task forces. But what's a kind of a global plan? So once the task forces deliver the report, what in your view what is the impact you expect from this, and what is your point of view how this will be taken on further into the future, and what actually will become of that output of the task forces?
Yes, I see two main outputs. I mean, the outputs that they already have defined in terms of deliverable that are very aligned with the main chapter, and also the contribution to the multi-annual roadmap, which is the global view of all the implementation steps that are needed. And this is which I think that everybody...
Hi, everyone. Thank you, Ron. Thank you, Kuba. And thank you, Ignacio. Have you had a glass of water there? I just wanted to pick up on what you're saying, and it's linked to the next session as well. Where we, in fact, have been trying in the past weeks, just recently, to see, look, how can we, and we've been calling it joining the dots, yeah? And this opportunity of the ScienceMesh perfect gathering to say, right, there are efforts ongoing. And in fact, in the next session, we'll see some different science cluster organizations showing how they're already working with CS3 and ScienceMesh. And what we wanted to do now that we're in, okay, January's finished, but there's going to be an adopter program as part of the EOSC Future project. I don't know when that's being launched. I think the Technical Strategic Board is putting that together, but that's a perfect opportunity for us to put together some simple EOSC in practice stories that are part of EOSC Future. The screenshot of who we are going to have interventions from in the next half an hour. Okay, we started the discussion thanks also to Kuba and Ignacio that brought in the point on how ScienceMesh and CS3 can do something for EOSC, and I think this session was sort of the beginning, and it's entitled Scientific Disciplines Embracing No Border Research Environment Thanks to ScienceMesh. And what's nice in this next half an hour is that we wanted to show that you can see either infrastructures or projects that have been funded under the science clusters and other projects, in this case, the CS3MESH4EOSC project, how they've faced some challenges and how they're addressing them by working on federation and interdisciplinary activities together. And the objective is then to pull out this very easy concept and story that the ultimate aim is to say, this is going to go into EOSC, by the way, isn't this wonderful? And we deliver some EOSC in practice stories that are easy to understand. So this is very close to my heart because it's something we cited back in 2017-18 when we put together the first high-level expert group paper called EOSC in Practice. And so this seems to be taking place. And what we said before is there's an adopter program going out in January, launched by the EOSC Future project. So please stay tuned to that. So we'd like to respond to that. And what we'd love to see is some of the interventions you're going to hear now from our esteemed panel will then get turned into these use stories, EOSC in practice stories that we've mentioned before. Okay, so without further ado, I'm going to pass the floor quickly to Xavier, who's our first speaker. And Xavier, you all have slides, I understand. So Xavier is an applied physicist staff member at CERN. He works on the ESCAPE DIOS, the data infrastructure for open science. And he's also coordinating the WLCG project on storage consolidation, data lakes and data access for the future HLLHC. So I'm trying to pull out from your profile the part where there's the interdisciplinary part with other projects. So over to you, Xavier. Thank you.
Thanks a lot, Silvana, and thanks a lot, Rita, for sharing. So I think we can skip to the second slide. I have less than 30, so I can make it in less than 30 minutes. In fact, it will be quite quick. So in a nutshell, let me introduce probably in 1 minute what ESCAPE is doing, which are the links with the ScienceMesh and the CS3MESH4EOSC, and some proposal to basically join path and go forward with some proof of concept. So ESCAPE, in a very kind of big framework, is trying to set up together a data infrastructure, a storage infrastructure, together with data management tools. This means to provide experiments, a way to do data management, to do data recording, put policies, replication rules, quotas, ACLs, at the service of the experiment. It is something that we in the LHC, it is done since many years, but there are more and more experiments which are reaching a scale where when to manage big volumes of data and big number of files is getting complex. So that's why experiments from astrophysics, cosmology, gravitational wave are adopting this infrastructure. We are prototyping this infrastructure to basically put at the service these tools, data management tools, data movement tools. Now, this ESCAPE is covering a fraction of this kind of big data or heavy-duty life cycles for the experiments, but also is opening the door to stretch it and put it at the fingertips of the researchers, students, outreach activities, open science, etc. That's why the data lake is being integrated with analysis platforms and notebooks. So you can have your notebook and then have a window through this big data, which is basically the many petabytes that are injected by the experiment. So the data lake is evolving through the collaboration with the scientists to explore new feasibilities and new handles in terms of metadata classification, data browsability, etc. So that's why there are possibilities, and in fact, there is the need to extend the scientific data lake to accommodate to very, I would say, very complicated workflows in data, to very simple access and use, like cloud storage. You put data there, it get basically in the background it gets fair, so it gets replicated, consolidated, and then it's easy to access for the user. So probably, Rita, you can move to the second slide, which is basically what is the meat of this intervention. So what is the goal? What is the goal and possible collaboration with ScienceMesh? And I wrote it here very raw, I think, is to provide a data management and access facilitating service, something that can be exported in the EOSC portal or the experiments can deploy and can use, which basically means an integrated data management and data access compound layer, which means software. You all know the Rusho, the data management, FTS for data movement, a common AI, etc. So this will be the main goal, to have a service in EOSC, imagine for sciences that have more modest needs, to basically make use of this service or the experiment inheriting this. So why this is a good idea, we think it's a good idea, is to bridge this diverse scientific data, no matter if it's a big experiment, if it's a small experiment, with these activities which are basically guided by the researchers, students, addressing outreach activities, open science initiative, etc. So on one side is a data lake, which are doing the heavy lifting for the data which is managed by the experiment, data injection, replication, this I mentioned. This is what is good data lake, but can be stretched. And then also from the other side, the science mesh can be stretched so the two things are merged together, because the science mesh can put together this data at the service of the population. I mean, this sharing with the different infrastructure, put it in a window in the notebooks, integrated with sync and share facilities, so the scientists can interact with the data, doing their analysis and doing scientific collaboration in documents, etc., plot, etc., etc., and also interacting with the home directories. This is no question. This could be a good way forward. Also interacting with the heterogeneous computing resources. So, what to do in this perspective? I think what we need to do is to provide some hints and basically try to build up a proof of concept to put forward these ideas. So, and offer the possibility to really connect the science mesh with a data lake. We need really to prove this and to show it. And how we can do this. I think enabling the science mesh activities in the Escape data lake is basically three things that we need to address first. The first one is to integrate the data management system of the data lake, which handles all of the big data of the experiments. This is Rusho. And the FTS, which means able to move data from site to site inside the data lake and also in the science mesh nodes. This is something that is worked on in this direction. I think the proof of concept could be quite easy to sort out. The second thing, which is fundamental, is to have a transversal authentication mechanism, probably based in the Escape AIM service, and ensure this token-based authentication is honored on the full stack of what I call the data chain, from the experiment injecting data to the last consumer on the other end. And to finalize, we need a catalyzer. We need some support in trying to set up this proof of concept. And in my mind, and one experiment that could be interesting to start with is LOFAR. LOFAR is very active in Escape. They participated in the data challenge that we did in Escape in these last 2 years. They proved they can run workloads, they certified data access from different resources. And also LOFAR is active in Science Mesh. So it sounds like a reasonable proof of concept to start with. So, and from, I believe my contribution with this question mark. What is your vision on that? I was quick. I hope I was clear.
You were, Xavier. In fact, I put in the chat here, something we discussed was to consider ScienceMesh as a resource within EOSC, right? So that is it similar to what yours? Well, that would be my answer to your question, right? In going forward. So
That's,
to taking it from Escape and then, you know, having it as the final destination.
That's correct, Silvana. So I can imagine a service in EOS which basically obscure or hides all of this complexity for the users. So you offer the service. Yep.
So I got cut out. Sorry, Xavier. What was your reply? I don't know if I got cut out.
Yes, that I agree. I think that the idea is to have, imagine you can have a service in EOS which hides all the complexity for user or for experiments. So you can use this. So you put data there, you put this behind, and then you basically give access to them and share this data.
Ignacio's still on, actually. And so with that, let's prepare also for our next speaker, from Mari Klimov, from Schok and University of Tampere. But I want to go back a second so we can move, and then I'll go back to Mari. Ignacio's on, and I saw, I don't want to push anything on Ignacio now, but I saw in the ESPRI conference that's been happening as well, there was a comment from, I think it might have been Francisca de Jong, who said, yeah, we love how EduRoam works, that no one, you know, actually understands the technicalities behind it, but it just works and it's simple. And, you know, we need to obviously consider these same features for what wants to happen then eventually in EOSC, okay? Feel free to put in anything in the chat here while we move on. So thank you very much, Xavier. That was wonderful and to the point, and you described the challenge, described what we could focus on what the end goal could be. Mari, hello, how are you doing? Mari is a development manager at the Finnish Social Science Data Archive, Tampere University, and she's also a member of the EOSC Association Task Force on Fair Metrics and Data Quality, and you work on different projects in EOSC. So over to you, Mari, thank you.
Thank you, Silvana, for the introduction and the invitation. So I'm here as part of my work in SOC on trust and repository certification. So that's basically my viewpoint today. And SOC is, of course, much more. I won't go into details. There's the website. You can go there. So next slide, please. So my starting point here is that different kind of repositories and services are key parts of a fair data ecosystem. And in this ecosystem, trust between different actors is essential. So that's the main thing. And then this trustworthiness can be determined by comparing evidence to requirements using an assessment process. So this is the very general level thinking. In SOC trust work, we have supported selected social science humanities repositories in their journey towards core trust seal certification. And if you don't know it, it's the core requirements for being a trustworthy digital repository. And it's for repositories that have a mission to preserve data for the long term. So that's the main thing. So there are several lessons we've learned, several challenges. So for example, there's a huge variety of repositories. There are generalist repositories, specialist services, technical service providers, and anything in between. And all of these repositories exist for a reason. So they all have an important role in the whole research ecosystem. But they have different missions and goals, different organizational settings, and very complex organization settings, different maturity levels. I think one of the challenges is that sharing of responsibilities is in many cases very unclear. There might be some sort of blind trust between the actors, but that's actually a risk. And the usual story is that services are working well enough for now, but lack of governance, for example, and lack of metadata and documentation make them vulnerable. And as a result, the data is at risk. And I think we can all agree that digital data is an asset that needs to be managed during the whole data lifecycle. So I mean, next slide, please. So that was a very general set of challenges, and I think I've learned this what I think is a nice picture from Hervé Loos and Ilona von Stein's paper, and it describes the FAIR ecosystem components. It's based on the Turning FAIR into Reality report, and I'm sure there are other visions as well, but this is a nice way and shows the complexity of the ecosystem, even though it's a simplified picture. So we need these FAIR enabling services, repositories, registries, and people and skills to ensure that the research data objects and other digital objects remain fair and usable also over time. So I think services and ScienceMesh, for example, is an important piece of this puzzle. It enables data management and good and fair data management in an important stage of a data lifecycle. So and when it comes to, for example, repositories and with long-term mission, for example, they can be using the same service. Well, for example, ScienceMesh, I think, to ingest data that's been produced on campus, for example. And if these repositories that are using ScienceMesh as part of the services, if these repositories can wish to get certified, they will need to provide evidence to back up their statements. And since they are all using the same service, they would benefit from common shared evidence provided by ScienceMesh, for example. And so even if ScienceMesh, because it doesn't have the long-term preservation mission, it's not eligible for COTRA seal, it's a vital part of the ecosystem, and these all services can work together. I would also I just want to conclude by saying that the world is not ready. So as I mentioned, COTRA seal certification is not fit for all. And while ScienceMesh, for example, can help repositories that have the long-term preservation mission in achieving COTRA seal certification, I think there's a need for different certification frameworks and evaluation of existing frameworks. And this goes for TDR, certification as well as to verification. So, and it's a developing scheme. Thank you.
Thank you very much, Mari. That was also to the point. But I think, would you agree also that thanks to sort of initiatives like these ones that we're hearing today, is sort of pushing the boat out to try and make sure that some collaborations can take place? You know, after sort of, I'll pass that's just a quick question to you, Mari.
Yes, yes, and we need to see the bigger picture and how the services and actors can complement each other and work together. And of course, there will be some competition as well, but generally speaking, it's more about collaboration.
Exactly, and as we were mentioning before, you know, trying to pull out a nailskin practice story from this would also be extremely valuable. SEoC is coming up to its final phases of one of the science clusters. It was one of the ones that began before the others, actually. It ends at the end of, no, it ends in April, actually. Yes. So it would be lovely to have as an asset going forward, this type of result of where the collaboration goes forward. And remember, ScienceMesh isn't part of an EU project. Okay, so the whole sustainability action is much more reinforced there. Moving on, thank you very much, Mari. We're moving now to Francois Perlin, who's representing PANOSH and the European Synchrotron. He's in charge of the IT infrastructure, the ESRF, and inside PANOSH, he animates the work package to facilitate the integration of the RI services within EOSC. It's perfect for this setting and this particular session. Over to you, Jean-Francois. Thank you very much.
Yeah, thank you. Maybe we can stop at the second slide, just a second. So just to present PANOSC very briefly, this is 6 data producers, so research infrastructures in the field of neutron or photon beams. That's all. We have also EGI, and we have we are working very closely with another project called Expanse, which is for the same community, user community. Next, please. So just to present the community, this is a relatively large community in terms of users coming every year on the beamlines for experiment, getting the data, but also in terms of scientific field, from biology to even high energy physics. This is very large. We have academics, which represent more or less 80% of the population of users, but also industrial users. And we produce data, a lot of data. Next, please. The project PANOSC and Expand have strongly focused on making the data fair. So we have a framework for the data policy that we are all implementing. We have developed e-learning platform for the users. In terms of data management, all the data are presented in data catalog. They are accessible through APIs. The data, we mint DOIs for the data, and we are working on DMP for the users. Next, please. But for today, maybe it's more interesting to talk about the service we have developed for the users inside PANOSC. So there is basically 2 types of services. They focused on data analysis mainly. We have the notebooks like many others, and we have also a solution called Visa, which is a remote desktop, which provide for the users the software, the hardware, the resources, GPUs, CPUs, and a direct access to the data to avoid the transfer of raw data by the users. Next, please. And the main challenges that are still on the table were probably around the data transfer. So we had 3 use cases for data transfer. One, which is a very typical from the community, is users having performed an experiment want to get the data back home. For this, we have put in place 2 solutions. One for the academic, or mostly used for the academic, which is Globus. And another one which is more, which is requested by the industrial quite often, which is IBM Aspera. The second use case was how a relatively small data producer, an RI, could archive the data, and we are working with STFC for that, using their ecosystem. And this is a clone that has been selected, and that is in production now and working quite fine. The third one, it's a bit more, it's a bit different. This is how do we transfer the data for users when they want to use a compute facility which is not on the RI. We can move to the next slide to explain a little bit more. Yes, again, there's an animation which I shouldn't have put inside. If you can go for it. No? Yes, perfect, thanks. Basically what you see in the slide is that all these RIs have their own repository or own archive. When they provide data analysis services locally, they will use NFS or local protocol that works quite well on the LAN, but are not done for internet. And here on the right, you have another service provided by some organization which are not necessarily part of the community. In that case, it's EGI. And the user coming for using this service, how could he transfer the data transparently? And how could he just ask the data to be transferred? So for this one, we are exploring currently at the moment EGI Data Hub, which is a one data solution, but other solution could probably fit the needs. And this is something that we can explore more. Next slide, please. And the last one is the software provisioning. This is typically for Visa or HPC solution or any compute solution. And when it's not local, when this is If you take the example of ESRF, we have some specific software to analyze the raw data produced by our instruments. Users will need this software and don't want probably to install them. They want to have them installed wherever they go for analyzing the data. So here we pick up CVMFS, and I see that in Mesh, CS3MESH, this is also something common. We are at the beginning of I would say, evaluating, because it's not deployed everywhere, but this is a solid candidate. And this is what we are working on at the moment. And maybe there is room for cooperation, common work with CS3MESH. That's all. Thanks.
Okay. Thank you, Jean-Francois. In fact, my question to you would be, so which is the connection with EOSC? And it would be indeed the part on CVMFS. So can we touch base on this in the coming weeks or months? I don't know when you're thinking about this, the whole sort of program around the synergies. And once you have some updates, then you can inform us. Would that be okay?
Yes, not very clear, but yes, we are working on it. We are deploying it.
Oh,
so
well, no, you said it was something you were perhaps considering. So that was
it's an evaluation, but we are more or less at the end of the evaluation. There is not much other solutions for facing this problem. But if you have experts and we have questions about CVMFS in terms of organization, when you mixed different organization of the repositories, when there is different organization publishing software, things like that. So we would benefit from experience from others, clearly.
Okay, that's clear. Okay, I appreciate the answer. Thank you for your timely presentation too. Jiming, you're up next. Then, if you want to share your slides. He's currently a senior researcher in the group of System and Network Engineering at the University of Amsterdam. And he works on different EU projects. And at the moment, the specific one is working around data for science theme in the EU 2020 Environmental Science Cluster Project ENVI Fair.
Yeah. Obviously, that was my CV probably some years earlier. But I can introduce myself. Thank you very much. Sorry for keeping you here because I have less flexibility for tomorrow afternoon.
Don't worry.
So I'm here. Yeah, I'm here to represent every FAIR project to explain you, the possible or potential synergies we can have with this CS3MESH4EOSC. So actually, I myself have been working for the ENVI community for more than 10 years, ever since the first cluster project starts. There was the 2011 called ENVI, and then we had ENVI Plus, and that was 4 years. And then now it's the third project, it's called ENVI Fair. So basically, along all these different projects, so the key mission is, we want to interact with different research infrastructures in the environmental and earth sciences and work with them to understand their, data management challenges from the very beginning when they collect the data and try to understand, the diversities for, of the standards and the diversity of the, the protocols, so that eventually we can tackle their common problems, common challenges, and to help them be more interoperable. Yeah, so that was the mission. And of course, each stage we tackle this on the, different aspects. In the very beginning, we tackled this, try to build a common language, made a reference model, and then we look at, different small pieces, make lots of different tools to manage the data. So now in the third phase, ENVI Fair, we try to take one step further. Can we really help them to move all the different digital assets or research assets from data software, make them really fair? Yeah. So what you can see from these diagrams, so all the infrastructure we are interacting with is really a big set. It's more than 20, and they're across 4 different domains. So and currently the main activities we're working on, making things fair. Of course, this is the most important things. And we have, lots of different task forces looking at different aspects from the PIDs, from the, the AI, from the, metadata standards, from, the policies, et cetera, et cetera. By working with these task forces, we try to build, recommend common standards, and then build a couple of, services based on what the individual research infrastructures are building. And then we want to deliver a kind of concept, which is called ENVI Hub. Yeah, through this hub, basically the end users from maybe, from the EOS context or from, the individual communities from the research infrastructure, they can find the resources from different infrastructures from the single point. Basically, maybe we can move to the next slide, please. From every hub, we can, enable the users discover the things, discover the online resources, digital assets, and then try to use these platforms to share their engineering practices, technologies. That's basically the first pillar we call knowledge base, and including a search engine, and more for human users. And the second pillar is called catalog. So the catalog is kind of service. We aggregate different metadata catalogs from individual research infrastructures. We ingest the research assets from there and put them to hub level catalogs. And that catalog provides machine-to-machine interfaces to enable automated workflows. If you want to access the data sets, if you want to access software services, you could get them and couple them to the workflow automation pipelines. And this will also be a kind of point, we are of course still under discussion, to make this as a potential point for the EOSC in future to ingest, make these as part of the EOSC catalog. And then, besides these two, there is a third pillar that is, eventually will be the virtual research environment. But for the moment, we just call these every use cases. And we're going to look for different kind of demonstrators by using the research assets from different eyes, and by showing how these assets can be coupled together as a workflows by using the resource from individual research infrastructure, but more importantly, how to do this across them with support from e-infrastructures and even with the public cloud. So the possible synergies I can think of, first, let's say, soon after we have the metadata catalog, the importance we're going to support is to make all these assets, accessible. Not only retrieving the metadata, of course, you want to access content, but how to enable the user or workflows, access data from multiple sources, and then share across different workflow processes or users. So that would be, the first, let's say, a kind of at a point we're going to, need a very nice solutions. The typical challenges I think we're going to face is, of course, the trustworthiness is one important thing, but the trust organizations, the repository is just one part. We also have to think about how to enable the trust among, these individual researchers, and how can we, allow users to define their own, trust share policies. That would be something, we have to think about, because that is very important, for the virtual research environment, for certain communities. If you want, also make your intermediate data products, not just the data products you retrieve it from the original source, isn't it? So you have to enable that part. And the second is, we think, the could be the possible, let's say, these synergy would be interoperable infrastructure automation. Well, access to the data is just the beginning of the scientific stories, and how to, move things around, and then how to automate, these on-demand services for computing, and also for storage, and, or during the workflow life cycle. Of course, at the end, you're going to put it somewhere for, to publish. But all the things, all the dynamic resources in the middle, how can we get them from, from where? What will be the service level agreement? How can we automate it? How can we, assure the trustworthiness? And can we also do this, with, a kind of interoperable support for these public clouds like Amazon, Azure, and those things. Of course, we can use this for, developing data service and operating them like DevOps, testing them, and for running, workflows. And the last is the virtual research environment. We have been actually looking at the Jupyter environment, just like many previous speakers talking about. In Every, we also look at it. My team actually will we specifically look at how can we couple these different VRE functionalities, make them as extensions on the Jupyter environment, so that user can automate cloud services and make the sharing, even access really the advanced data sharing services like a peer-to-peer file systems or even blockchain, those kind of things, seamless from the Jupyter environment. So that would also be something we are looking at. Of course, I think lots of functions using the service from the service CS3MESH probably already have some mature solutions, and how to couple this with the future Jupyter VREs. That would be something I think in the rest of the Every project we can also look at. And those are just the points I enumerated based on the access part, which more close for this panel. Of course, within Every fair, there are many other technical issues. Majority effort now still we're spending only let's say the metadata semantics ontology types of topics. Yeah. So okay, I'm going to stop here. This is just a quick summary of every fair and the data challenges, etc.
Thanks, Jimmy. We're wrapping up the session, but we have our wonderful last speaker, Mark van der Sande. While you prepare that, Jimmy, what I'd like maybe to see though is maybe that for the next step that we try and pursue this, as I said also to Francois, as a concrete collaboration. So we really need to push this boat out further and say, right, we've tried this. We think Science Mesh could be the answer to. I'm not trying to sell Science Mesh, but when we talk about synergies, we want to give back to the EC the assets that are going to work, and we're showing nice collaborations, and we can do it. If we can, this is what we should be doing in the next phase. Thank you very much, Jimmy. Thanks. Wrapping up, Mark van der Sande. Thank you, Mark, for your patience. See, we are managing it, and we still have 41 participants online. That's great. Mark is working as a research service specialist within the data preservation services team at SURF, and you're involved in many EOSC related projects. In fact, seen your face in many things, and you're always a great contributor. And you're also a member of the EOSC Architecture Working Group, and you're on the EOSC, and currently you're working on the TF on interoperability between data and services, correct? So over to you, Mark. Thank you very much.
Yes, thank you. I see that I'm already sitting in the dark because becoming late. Yeah, on this slide, I try to explain a little bit where we see the challenges. EUDAT is an European organization providing a collaborative data infrastructure, providing different kinds of components to serve communities to implement better data management practices. And one of the challenges which we see is if you look at the vision, data is shared and preserved across borders and disciplines. It is very similar as, for example, what EOSC is also having as the aim to provide. But there you also have one of the biggest challenges, and that is mainly across borders and disciplines. And if you look at the diagrams below, there are many different communities, but also there are many different infrastructures providing services, collaborating with those communities. And very often they are developing solutions which are working very much in one community, but not always work in any other community. And one of the things is what we try to do with EUDAT is to provide common building blocks which can be used across different communities, but also have them as an interoperability building blocks. So therefore, what I currently see as one of the biggest challenges is technical interoperability, because if you look at all the different RIs, but also the infrastructures, they still develop the services and the solutions more in silos, bespoke solutions. And I think we try to come to more general solutions which are interoperable across the different infrastructures in itself. Next to technical interoperability, you have also the access to resources, and that is data and services. And that is access to the physical services and resources. For example, if you look at the AI type of challenges which we still have, but it is also not only technical, it is also policy-wise. So if you have technical, you are allowed or get access to a service, does not mean that you are allowed to get the service because you do not have the rights to get to those services. And that is more a soft part of interoperability. But that should also be overcome, and then not only for between a research infrastructure and a provider or a community, but more in general. What kind of agreements can you have more in general? For this, I also put in the logo of EOSC, and I think that is one of the drivers to see how you can overcome. And if you look at for the EOSC Future project. There we have a big collaboration with many of the infrastructures, but also of the different science clusters. And I think that can be a platform where you come together to see, okay, how can you overcome those challenges, but how can you come to consensus to which kind of standards to use, but also, for example, how do you develop policy so that you can get access to the services and resources which are across and provided by the different infrastructures and RIs. If you go to the next slide. If you look at this, B2Drop is our sync and share service, which is based on Nextcloud. And I think therefore there is already automatically synergies with the CS3 community and the Science Mesh to see, okay, how can you connect those together? But as I think is also shown already in the previous presentations, the Science Mesh is not only about sync and share. It is a platform to connect, but you have much more services which are of interest of the communities, which they want to use. They want to use for data analysis, but also for assigning persistent identifiers or make data discovery or publish data. So therefore, I think what we should look at to see, okay, what are common approaches on the interoperability? How do you connect to computing and analysis services? And I think there's already some initiatives within the Science Mesh where they are working at to see how you can do this from a sync and share service, but maybe we have to expand this to see how you want to do this for other type of data platforms. To look at common publishing workflows, because if you have the data available, you do the computing and analysis, but you want to also make the data available and share this with others in a different way as publications, but also make them discoverable. So also there you can see, okay, how can you make this easy workable in different platforms so that you can common tools, common plugins, type of interfaces to make this available so that you can, for example, publish data in Zenodo, which is Invenio based, but also, for example, B2Share. Luckily, this is also Invenio based, but you have many different repository platforms. And if you have tools so that you can work with those different repository platforms, then I think it will already help many of the researchers to make the data available. Federated AI is still one of the biggest challenges. How do you get access across different services, but also if you have access in a service, how can you access all the services from that service? And that there also are initiatives already also within News Future to try to solve, but also come to an EOSC AI federation where you can connect those AIs to each other. Then making services and resources available across infrastructure, I think, because you have those different infrastructures, and it would be very helpful if you can connect services across the infrastructures, but then also have to look at the technical interoperability to be able to do this, but also on the policy side that you are allowed to do this. And collaborate on common use cases, because most of the work, I think, is very important to go further to have a common use case, because that is also an incentive to collaborate and try to solve things. And I think there are already good matches between the different infrastructures, but also, for example, within CS3 MESH4EOSC, but also within News Future to see where you can bridge on common use cases to start working. Yes, this is
nice, Mark. Thanks. I think that was a good concluding point as well. That it clearly draws into the opening of EOSC Future that you're also involved in, and I think I'd like to think on the basis of this session also it's opening different avenues to push the common use cases together in the next weeks and months. We're done, and I'm going to pass the closing remarks to Kuba. Thank you very much to all panelists. Thank you for your perseverance and staying on, and thank you very much. We hope to see lots of EOSC in practice stories coming out of here. Over to you, Kuba. Thank you.
Thank you, Silvana. Thanks a lot also for managing this session in these circumstances. And yes, I think what we have seen is very promising, because I think in many of those presentations I could identify elements which are very clearly an opportunity for synergy, either at the level of the infrastructure, for example, like it was presented on the last presentation, to essentially have, for example, EU.infrastructure interoperable with ScienceMesh, or at the level of actual use cases in the research infrastructures and the new research communities, exploiting some common tools and approaches, maybe through Jupyter notebooks, maybe through software distribution, through access to the digital repositories, and some, perhaps not only at the level of integrating technically these components, but also at the level of maybe sharing some practices for the, the best practices for the researchers on how to use these different tools and these different infrastructures. So thank you very much to all the speakers as well. And I think we definitely need to follow up on this. Perhaps, Silvana, we can discuss how we can follow up.
Yeah, I think also, sorry to interrupt, if this adopter program comes out that I've understood, and I'll find out more about this, as soon as this is out and there's the application form, I certainly think that a takeaway from this session needs to be that a set of applications are submitted. And that would be, a perfect takeaway from these first collaboration discussions.
Yeah, okay. All right. So I think this brings us, unless anybody would like to add anything, anybody from the audience would like to share some thoughts with us on what you have just heard. I think it's an opportunity for EOSC, but I think it's also an opportunity for ScienceMesh, and it's an opportunity for many of those infrastructures that you have presented. And I think our job is essentially to try to come up with a win-win situation where we can really connect these dots, and everybody can essentially benefit from these synergies. That would be my take on this.
Yeah, also think that ScienceMesh, having heard these presentations, that ScienceMesh can form as the glue between a number of these projects.
Yeah, in particular, in ScienceMesh, it's already a multidisciplinary infrastructure, because essentially each node, existing node in ScienceMesh currently has access to another discipline, another user community, and in this way we are building that multidisciplinary aspect of the infrastructure as well. So essentially, the node operators are the way ScienceMesh is conceived is that the node operators, so the nodes in the mesh, they're already very closely working with some particular either local communities or or are also providing services in some infrastructures. And for example, a very good example of that is Escape, where we have found many interesting synergies, because the same site is part of ScienceMesh, it's also part of Escape, and it's part of particular communities such as LOFAR, for example. You couldn't get a better match.
And part of UDET, and part of
also part of
Future, and
yeah. Another interesting aspect in general is, currently all the nodes in the mesh, essentially they have their own local user base, so people that have access through that local node. But probably what is on the radar of the European community, I imagine, is also to cater for people that do not have institutional access to services. So and I think this aspect is not yet fully covered in the ScienceMesh.
I think, just to comment on this, I think, for example, EUDAT can provide some of those, because many of the services which we provide are also public, and you can register on those services, therefore you can get access. But also, if you then connect to the ScienceMesh, then you can also already collaborate with people which have access to other kind of services and different nodes.
That could be one possibility, for example. Yes, that's a very good example. So I think we have really a very rich
Oh, sorry,
yeah.
Giuseppe has written something in the chat.
Sorry, yeah.
Yeah, which is nice, and it's a good point to sort of chat more on this topic tomorrow at Gather Town. I don't know, maybe we should also exploit the fact that we should maybe feed back also to the EOSC Association too, and we have Ignacio on the call too. That can be a very good linkage there. We have other contacts clearly. There's Bob and there's Sarah too. But it would be, I don't know if we need to do another maybe coordinated gathering in a couple of months' time, if we have some to look at, some results going forward on what has been discussed here. Maybe 2 months is premature, but I think we should action a follow-up in addition to the idea around the adopter program. Otherwise, it'll be a missed opportunity, I think, and we'll just go off and do our own things. Whereas we need to make it our duty to follow this up and see where it goes. This is something Trust has to do within the remit of EOSC Future, so we can certainly take the responsibility for that. But I agree, maybe if we also have something formally organized, it forces us to do it, doesn't it?
Yeah. One vector is to look, for example, for sites in common. If there are sites that they are already in the CS3 community and they are part of already of one of the S3s, that's a very natural connector, let's say. And this is one way of expanding the network, and the other way of expanding the network is through the user communities. So essentially, if we have some user communities in ScienceMesh that are also in some other sites that are not part of that infrastructure, that's also another natural route.
But okay, I mean, I know we can't discuss this now, but how do we get access to these to those on these other sites?
Yeah, I think we'll need to perhaps have a look and get an overview of these different communities that are present on the current sites, and starting from that list, we can essentially engage and try to understand.
Okay.
Okay. So, any other comments or wise words? Thank you very much for this very long day. Thank you, and thank you to the organizers. Thank you to the participants, and thank you to all the contributors and the speakers. And I wish you a very pleasant evening, and we'll stay in touch, right?
Thank you.
Bye.
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 Bye.